In a world that walks the line, there's a rare few who think outside the box together form a crew to break the equations not bound to any rule, exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool to make the vision realize energy and matter in a duel. To a great, to a duel.
Hello, everyone. My name is Nathan, otherwise known as Old Man Bill. Joe, what's going on?
Hey, Nathan, everybody. It's another Saturday, isn't it?
That's right. All right, man. We're going to talk a little bit about some cold electricity today.
It's freezing up in here.
Kind of a misnomer of understandings, but we'll get through it. I did some work on some projects, and I'm dealing with some radiant energy out of my Tesla coil, and I think it's different than the cold energy. And it's kind of been detailed a little bit, and I just finally think it's crossed the line where I just know they're different.
Mm-hmm.
It doesn't mean that they can't be rectified the same. It just means that they're different. So what I'm dealing with is a giant field that just goes through everything. And it doesn't matter what it is. Like you say, okay, can you get it in a Faraday cage? Well, it blows right through it. If you say, can you put aluminum foil around it? Well, hold it in. Nope, goes right through it.
Scalar fields and ELF waves do that. they tend to do that rather well. So, yeah, makes sense.
Well, I wanted to make the distinction because when we talk about a cold energy circuit, you run it in the negative and you get it down to, degrees at room temperature and a little bit below, and it keeps all the parts cool. But in doing that, it still negates eddy current. So, or beats Lenz's law, I should say. And this energy does the same thing. It's just so much more of it. Like, it's not stopping at the little bit that you think it is. So when I multiplied out how much energy there is, I could probably pull 5 to 10 times the amount of energy just out of this one field than I could anything in a negative energy circuit that I can run.
Now, I guess one of the beauties of that is because it lacks confinement, you really don't have to worry about saturation of an area. You could just pull straight from a state of equilibrium, which is, a much different thing, which is awesome.
Yeah, it's okay until you try to run it in a system where you need confinement. You need it to stay in one area.
Right.
So we're going to have to find something that confines it. And I don't know what that material is. I think it's mica, but I'm not sure. I'm going to have to buy some. But if it can't be confined, putting it in any kind of car or anything like that might be out of the question.
Well, I think, whenever you're talking, that low frequency or just pure scalar, I really think that in order to get it back into a compressed state, it has to be in a pulse fashion and in a state of collapse. So, during that state of outward two-dimensional 360-degree propagation that generally occurs, from a source of emittance, in order to utilize it, you would have to have it pulse and collapse, and basically have it interfere with itself to be able to confine it, because unless if it's in the collapsed state, it probably, I don't know of anything that I've heard of that would be able to necessarily contain it.
That's the hard thing. It's usually the one containing something else. It's not the one being contained. You know what I mean?
Mm-hmm.
So that's the hard thing. Once I get that solved, then I can start building out the energy further. So one of the things that I didn't realize, Joe, was I have things in the cabinets below where I'm working. And I didn't realize it was taking effect to the energy in there. So if you can imagine it, if I had light bulbs in the cabinets, they would have been lit up bright as day.
Yeah. That's awesome.
I have little jars of nails and stuff in there. You know what I mean? Grandpa had he turned them in. You know what I mean? Hooked the lid up to something. Anyway, that thing was like completely energized in there underneath the cabinet, and I didn't realize it until I go to turn it on one day, and I'm looking and I'm going, "Why's my light turning up when it's on the ground?" You know what I mean? And then I go, "Oh, well, that's not good. Maybe I should clear those things out."
Well, think about what that's doing to the power, like the Romex lines and stuff in your garage.
I guess I never thought about that.
Yeah. Yeah. I mean, honestly, it would be interesting to know how your meter might even be affected by that potentially. Just to know whether it's having any sort of impact on the returns of the wires back to the meter. For the better, it could be for better or worse potentially, which is interesting to think about too. But you might even just have more intense magnetic fields around the wires to begin with that aren't contained necessarily by the insulation.
Maybe you see, magnets have no effect on this. You see, I'm trying to find anything I can. You know what I mean? I've spun magnets. I've done everything I can to try to find something to hold this field just a little bit, just some sign to say, hey, I'm here. And I haven't found it yet. So there's things that it works less well in, but it's not so much holding in the field.
Yeah.
So,
I mean, let me ask you this. What's the context of the field containment that you want to reach levels of saturation with that particular field when there are other fields going on?
The biggest field I'd like to reach is about an 8-inch diameter field by about a foot.
Okay.
So my thought was, if I can create a magnetic field around an 8-inch pipe, can I get it to hold it in? I mean, that'd be a place to start.
Here's where I see the problem with it. Provided that it's scalar. The methods of containment that are used are all off of power density ratio differentials, right? So when you have a higher inward energy and then you have other fields within it, they're contained by that more powerful outer field. When you have scalar and it's not contained, like you said, right? Obviously that is the effect that's causing the internal containment of the other fields, but not of itself. But because it doesn't necessarily because it's in a state of potential, it creating a differential, an energy density differential ratio strong enough to contain it when it doesn't have a value might be rather difficult, which is why it would have to be in a collapsed state, I think. Now the question then becomes,
there's no collapsed state.
Well, I mean, if you were to introduce other fields into it, potentially you could reach a collapse state.
There is one thing you didn't like, Joe.
What's that?
Mineral oil. If I did that cylinder and I fill it with mineral oil with the second cylinder, so, gap and then fill it in, that may contain it.
Well,
it'll slow it down.
Yeah. I mean, when you're talking about energy densities, generally speaking, there is the other side of the coin. Analogous to that would be matter or material density, and the phase of the matter may be significant because you have a lot less resistance, so to speak, in air or atmosphere, and you have high vibratory carrying, in solids, and the denser the solid, the better it carries. Liquid's the only thing that really acts as a medium to actually damper and contain. So when you're talking about like high density liquids, liquid phase states, I mean, that would make sense because it could damper and contain.
I think that may do it, but here's the thing: will it compress like gas? Because Tesla always said the radiant energy would, or or energy does. So I'm curious to see if by doing this, it makes it stronger in that local area. You know what I mean?
Yeah, I mean, if there is a field that's forming within a mineral oil medium, really what you're looking at that point is, a form of cavitation, and you'd be looking at a plasmoid at that point.
Do you think it would form one if I did that?
I mean, that's hard for me to say. I mean, but if you had results showing that there's voids and pockets that are measurable with energy, then I would say that's exactly what's happening. But they might be microscopic, which and still attracted to each other, which just adds a layer to the difficulty of being able to observe that.
Well, if I put it in a clear PVC and then I fill up the outside, you can still see a little bit inside, so it show like a lightning inside if it did it. Because this stuff doesn't spark over. You see, that's the thing. Unless it's like right next to it, like this little tiny bit, we get no spark. So
yeah, this is where like laboratory equipment comes handy, because it becomes very hard to, like, I would say that the best way to detect something like that, whether or not there's some form of microscopic cavitation, accumulating in a certain area of liquid substrate, would be like to run like a laser, like some coherent light through it, and then catch it on the other side of a clear vessel, and just more or less see what a measurable result of that would be. If there's any sort of refraction going on, or any sort of luminance loss and things of that nature, I think that would probably be a pretty adequate test to be able to see if that's going on.
Nice. I can always if I put it in a jar of mineral oil and I just create a sphere out of plastic, and then I ran a coax cable into that and sealed it, and then hooked the coax cable to the center of my Tesla coil, right? Then I would have basically the field around it. I could see if it holds it or not without.
Yeah, crazy. Okay, I see what you're saying. So a void within a void contained by. Okay, I see what you're saying. Basically, seal off the globe so it's in its own. Yeah. Okay, that's cool.
The only thing it would get is the wire, and we could detect that because the wire only comes out one side. You know where energy comes with the light, and then if you put it down below it, it should dim and then go out. And I can get that Tesla coil down quite a bit.
Yeah, but I mean, if you have it to coax, also, I'm assuming that it's escaping the coax. So realistically, are you really going to get a dimming effect if it's still kind of hooked up?
If I use a like a hose, a clear hose, put a rod to the center of it, you know what I mean? Something like that. Something where I can get distance away from it. I just got to get distance away to make sure it's good.
Right.
You know what I mean? That's it. And if I can create that, then I can find out if it stops. And if it stops it and I can contain it, then I can compress it probably. I'm thinking it will, because you're still pumping in the energy. So I don't know if it's just there, or if you get what I'm saying, or if it's compressible, because there's been no mechanism to compress it so far.
I don't know. What comes to mind immediately for me, now that we're kind of pondering on it, is it would be an interesting experiment to see if you were to have liquid mercury, and then resonate the liquid mercury.
I'd never use that stuff.
Yeah, I mean, is there a reason? Fumes?
Because as soon as it becomes gaseous,
yeah,
then everybody dies.
Well, I mean, you got to have ventilation.
Yeah.
But
I don't have a lab.
that's
You know what I
fair.
mean? There's no running that stuff.
Hey,
for me.
listen, I grew up irresponsibly. My dad literally bought me he worked at a school and they used to have science labs that they would purge of stuff every so often. He brought me home a 1 liter bottle filled with liquid mercury and he's like,
Oh
here,
my
play with
God.
this. Look, you float a rock on it. Oh, look, like put
play with
your
it.
finger in it. It's like a party trick because you know what a 1 liter like plastic container filled with liquid mercury weighs? Weighs like 35 pounds.
Is it really?
It's very, I don't
Wow.
know that's exactly, but yeah, it's heavy.
Wow. Yeah. No, that I know everybody talks about mercury and they want to make it part of all the experiments. They hear all these things about UFOs, but it's dangerous, man. Not so much in the state that it's in. It's when you start messing with unknown energies and putting it in there.
I mean, listen, I'm not going to argue that, and I think even when you look at the more advanced like propulsion systems, like concepts like MHDs and stuff like that, and they utilize mercury in it. It's all in a contained, environment. It doesn't have to be ventilated because it's sealed. So,
Yeah.
Yeah.
Anyway,
apparently Brandon thinks that's why I'm messed up, is because I played with mercury when I was a kid.
yeah, I explained this, Joe. So, does it need to be captured? And the answer is yes. Only because when you amplify this stuff, you just imagine this. You put it outside in your backyard, right? Like where your air conditioner is. And if I turn this thing on and brought it up to enough energy to do your house, I'll light up your whole house while you're walking through the energy of the field. That's about how it works. So
Yep.
If I don't contain it, I don't know, you may grow a tail. I don't know what this energy does. You know what I mean? To people besides my burrito. I mean, it's kind of interesting to look at it that way, but yeah, it would be bad. I mean, it could potentially be really bad.
Yeah, I mean, you kind of got me there because realistically, transverse waves and stuff like that, are one of the, probably a big component of like cosmic rays and stuff, aside from all the other types of radiation. So I think that it plays right along with that. But think about it on the bigger scope of things too, because this stuff is being emanated at us from the sun at all times and it's not being stopped by our atmosphere. The question tends to be that is the magnetic field that manifests as partially a result of it, B, how much of it is actually pushed out because of the magnetic field, since you're dealing on the planetary size. I think that that's an interesting kind of consideration to make. Maybe if the fields were strong enough, maybe it could, act as a form of containment. But, again, you're talking differentials. So you're going to need something really powerful to be able to squeeze that waveform down and compress it toward the end. And then that should probably, if it doesn't collapse at the end of the waveform, it should create like a area of diffuse field, which, depending on what the densities look like, would kind of be deterministic of what was there. It might be plasmatic, it might be just magnetic. I don't really know. I don't really know, but it's fun to play with. The idea.
Yeah, it's interesting. So I only bring it up because I already transferred the energy to hot energy. We can convert the energy. That's not a problem. And I know it's kind of controversial to a lot of people and the way they think about energy, but I basically inverted the field. So I know that it has no magnetic value, and then I gave it magnetic value is what I did.
Mhm.
So I took the dielectric, put it inside the magnetic in order to create it. Now I pushed it back out and converted it back. Now I have usable energy again. And
I love
I
it.
think I think people don't understand why that is. They think, oh, you just reduce the amps, you just reduce the voltage, you did something else. And well, those things don't work that way.
No.
It just doesn't. You see, when you reduce all the amps in something down to, well, you can't get it all the way, it creates a static field. So it'll make all the hairs on your arms and everything stand up. This field is so big that it literally should have stuck all my hair up in the air as soon as I came next to it if it was static, right? So is it an amperage field? And you go, well, it is if you think that field is magnetic, you'd be wrong. The amperage field is scalar. And that's something that's very hard for people to choke down. And they keep telling me I'm crazy, but it builds out that way. And I only do things the way they build out in the lab. You know what I mean?
Yeah. Well, it should grow as it propagates outward too. So it shouldn't have a loss. It should actually have either be somewhat equalized as it expands outward, or it should potentially even grow.
Well, see, I disagree.
Okay.
It's going to have loss at distance. So the thing is, it'll then stop. And then where it comes near another field that's resonating the same, it'll start right back up.
Mhm.
It doesn't need, remember I showed you my Tesla claw? I can get it to resonate. I can shoot plasma right out of that sucker with absolutely no primary. You know what I mean? No magnetic field in there. I'm just doing it by ringing it. But that's what the scalar is.
Yeah.
So
Well, they said scalar is, analogous to sound waves, and sound waves are just generally scalar in nature in the first place. So, the resonance is directly related to sound because that's all related to resonance and oscillation frequency. So it's interesting to think.
yeah, sorry, I'm sending Mike an email right now. Anyway, what I was trying to, how to say this? The energy conversion is so good, Joe, that my Rodin coil when I set it up, right?
Mhm.
So I use it as a 1-to-1 transformer. Basically, hook one wire to it, hook one wire to any other wire I want. Doesn't matter which one. Because it's saturating the core, it doesn't care which wire I hook to.
Mhm.
All the wires now become equal, right? The good thing about that is I can keep adding more every time. Add more lights, add more cans, you know what I'm saying?
Right.
So my conversion's higher as long as it stays saturated. That's the whole key.
Right. That would be the key is keeping that density level just up there and high. Yeah, that makes sense. Well,
So
you said it yourself. It's like the cup that doesn't empty. It just you kind of empty it and it fills back up.
I think that's what's one thing that people don't understand about 0 point is if you don't get that field that keeps filling up. Like I was looking at the serial generator. Serial, I don't know how to say it. Anyway, it has all those things that goes around, right? And I was listening to the guy said, it started to cool down on a guy and I knew he had it. It was the quote. And I said, well, I know what you're looking for. Are you building it to look for that? And it's one of the key things. So I keep seeing this thing and the hole in the center doesn't go all the way through. It goes down to a board and the board stops it. So I go, are you really building it for the effect that you want, or are you building it just to build it?
Right.
A lot of people think it's, hey, spinning little things going around, that's great. Schauberger did that. He spun the air around the entire thing, but he did not forget to create the vortex that goes in.
Mhm.
How do you get it colder in the center? You got to create that vortex. How is that generator doing that? It's based on the principle of each thing that you put in, from the copper to the magnets, every little thing gives you a fourth direction. Because it gives you a fourth direction back to the center, you've now created your donut shape. You've created your spin. Now the center should cool down.
Right. And well, I think what people ought to remember too is that toruses are not 3-dimensional, they're 4-dimensional. And 4-dimensional means that there is that extra plane, but that extra plane also is the mechanism of time. So time is frequency. So when you're dealing in that sort of motion in itself, it's really only at the pinnacle of that center, and that's why the time dilation occurs too, is because you're on that fourth plane and you're compressing a fourth plane. Yeah, so it's kind of important to remember that, because the interesting thing about toruses in general is we like to think about it in a 3-dimensional sense, where you have this outer and this inner, and that's true to a degree, but what actually happens to also be simultaneously true is that the inside of the torus and the outside of the torus inherently are the same. I know that's hard to wrap your head around. It's both inside and out simultaneously, right? So that's just the nature of upper dimensionality. And it can be inside and outside simultaneously because, again, it's the mechanism of time. So there's a point where the inside will become the outside and the outside will become the inside, but it exists in reality of things actually simultaneously as both, which actually kind of goes back to like a wave function, and a collapse of a wave function. So, just things to bear in mind and tie these things together for you.
I think one of the things people miss is they're opening their garage, right? When they're running this thing. You can run a full blast with the garage door open. You ain't going to get the effect you're looking for. You never will, because it's about confinement.
Mm-hmm.
You see, when you're building one of these things, if you're in your garage and everything's shut down and sealed up, now the energy flow stays in your garage. You see, that's one of the parts people always forget. It's the room itself that makes the energy flow. So if it flows through, you're building energy through that area. But if you're outside, it's like peeing in the wind, man. It isn't going to do you very much good. You have to confine it, and then it'll flow. You have to be able to pull a little bit of magnetism on that oxygen to get the flow started. That's why there's so much of a magnetic field going on in different directions. You have to be able to do that. You see, a lot of people don't know that. And then, so like if I took a motor, this is the crazy thing. If I wanted to take a pulse motor and run it negative, every single coil would get negative energy. Why? Because every single coil normally would create resistance and heat. As soon as the magnet goes over, it creates a field of its own, creates resistance and heat. But if I add cold energy to it in the beginning, on each one of the pickup coils, right? Then I put it in. Now it builds on the inside. Remember that flipping field I told you about? Mm-hmm. When I flip it inside, now I force it to go to the inside of it so it cannot create that field on me. And now I defeat Lenz's law. You see, when you're looking at a pulse motor, if you don't know that you have to put it in negative first, you'll run it, okay? And you'll get a field and you'll get it going, but you're not going to pick up the energy I'm going to pick up out of it because I already primed the whole pickup coil setup with a little bit of energy. And you go, well, does the energy build then on top of what you put into it? Well, yeah, it does. It adds more energy into it. You didn't have to convert anything or do anything else to it. It just adds to it. But because the field's on the inside, I now have zero resistance. So I might as well be running this thing, man, in an aluminum shell, you know what I mean, with just wire. This thing's going to just fly.
Yeah.
You
Yeah,
see
I
that?
mean, right, the sequencing and everything like that and the act of the flip. I mean, it metaphorically kind of works like you know, a guess which hand game, you know, and you see which hand it's in the whole entire time, but at the last second you get that quick thing that just happened, and it's like, oh, I know what's in that one. Oh, sorry guys, you know, and that's sort of it. You beat Lenz's law that way, and it's super it's super cool to do it.
Well,
Um,
it's not necessarily need to be a timing thing at that point, Joe. It's just once you create the negative field in it, it builds as a negative field.
okay.
So instead of the field being out here and growing, I put it in here in a confined space. Now, the only place it gives it any kind of resistance is in that confined space. So now, all the effect here, all the effect here that you normally get coming in and going out of it, it's gone. I made it in such a confined space, it cannot affect at the degree it once did. Now it must take in that energy the way I want it to go in. That's, you know, when you have cold energy because you can defeat Lenz's law every time. So it's just interesting to think about because people don't think about that. They go, let me just run the magnet over the wire.
Mhm.
Well, as soon as you run magnets over wire, we all know it stops the magnet if you don't push it, force it through, and it creates heat. Well, it's called cold because it's not creating heat, but it's still absorbing all the energy.
Right.
It's a forceful way to do it. You know what I mean? You have to change it and flip it. But if you see it as a static field, you'll never get there because it'll still turn hot on you and go to, you know what I mean, a more magnetic field. The more and more you put the magnet over it, you know what I mean? If you see it as a flip, then you understand that, hey, he just removed that whole barrier that's in our way. You know what I mean? You get why I'm trying to define it in the way that I am?
Yeah, no, it does make sense. I just simply never thought of it that way. Um, yeah, yeah, but I'm still kind of absorbing it, but I understand it. Yeah, I'm just thinking about the application, you know, because my mind goes to the next. You know, I hear what you're saying. Okay, cool. And so what's that mean? You know, and that's taking me a little while to digest, actually, more so than usual, I think.
Well, it's creating energy without resistance. So if my motor runs at 2,000 RPMs with the resistance, and now I can pull 4,000 RPMs with zero resistance, I just doubled the amount of energy, right?
Well, right. I mean, the further you go is the closer to superconductivity that you could ultimately reach.
Now we're getting there.
Yeah.
So everybody talks about that kind of stuff when it comes to anti-gravity and stuff. They don't realize that in the state that you're in hot energy, it's impossible. I mean,
well, I mean, yeah, but at the same exact time, like, isn't that common sense when you look at how we know superconductivity to actually work in a laboratory, and we know that the closer to absolute zero that you super chill all these things, that the physics becomes broken, and how liquid helium drips through solids and stuff because it's literally molecularly quantum tunneling itself through solid matter. Like, you know, people need to understand these things because that's known science, you know.
But that's the problem. They're misunderstanding what the effect is and what the cause is.
Right.
You see, they're forcing the cold in there, right? They're absolutely brutally brute force putting it in there, right? They're not really realizing that should be the effect, not the cause. And that's why it's taken so much to force it in there.
Yeah, well, I mean, when I've been saying all along that everything in reality is just an entire sequence of of differentials, energy density differentials, pressure differentials. The whole entire reason that that works the way that it does is because when you reach everything at near the same temperature, in this case, we'll just use temperature as an example because it's what we're kind of talking about. That creates a state of equilibrium, and there no longer becomes differentiation between this and that, because the molecules are pretty much chilled to the point where they're moving similarly at a similar resonance regardless on both sides, and the densities become more less relevant when those molecular similarities are in place, creating an equilibrium, creating like, I don't want to call it broken physics because we know physics is broken, but like that objectively breaks physics.
Yeah, well, it shouldn't. That's the problem. This energy shouldn't break physics. It should define it.
It
And-
should define it. That's perfect that you said that, because that's absolutely true. Breaks
So-
the common idea of how physics acts. That's what I was trying to do.
Well, Gerald always says it's a room temperature superconductor.
Mhm.
It's because he's using the room as his energy source.
Right.
And the size of his room dictates how much energy he can potentially put into it. That's the key to his device. It's continuously rotating energy through it. And the more that it rotates, it's like every piece of energy that goes through has sticky fingers. And it's grabbing as much as it can as it comes back through again. And it keeps doing it until all of it starts to go through there.
Yeah.
You know what I mean? And that's kind of the key to this is you're
Well,
going to get.
Sorry, I don't mean to interrupt, but the simplest way to say that is he's by creating that extensive field and being within it, let's just say, right? All that's doing is breaking locality. That's really what it is breaking locality. So, you've just made yourself a confined microcosm within the macrocosm, more or less.
Yeah. It's called a room temperature superconductor, which means the room is a variable. And I've yet to see the calculation where they calculated the room. You know what I mean?
Right.
So it dropped below room temperature, which means it has more energy in it. You saw my test, right, with my rodent coil. I just pull the wire out and it just has energy.
It's still going. Yeah.
Yeah. Because it's starting to get on that level. Now, had I driven that thing further down and let the natural flow of that coil run, it's making it colder. You see, that's the reaction is the coldness. The action was what I did in the flow. That's where they get this whole thing screwed up. They're brute forcing it, and they're not realizing what the actual thing is. They're way off.
Right. Well, it's like it's like a drain in a bathtub, right? So you fill the bathtub up, you pull the drain, and then the water starts going down. If you turn the water off, the water's there's still water and it's still flowing down until there's no water left. And it's sort of the situation at hand.
Yeah. That's why they don't understand it, because they're super chilling something when they should realize the cold comes because of what the energy's doing. You shouldn't try to brute force the cold because you're failing the system by not understanding that.
Yeah.
What's up, Mike?
Hey, how's it going?
Well, pretty good.
Hey, Mike, what's doing, man?
Good. Thought I'd just come in and hijack.
Well, welcome to the talk.
Yeah, we're talking about room temperature superconductivity right now on the energy and how it flows in order to drop the temperature of it. But really, you're adding energy because you're adding the flow of the room energy to it.
Right. A lot of people don't realize, too, that your refrigerator in your house is an over unity device. It actually exceeds a 1.0 coefficient. And yeah, it's right in front of us. It's been used for years, refrigeration. So
Your microwave has superconductor in it too when you have that
The magnetron. Yeah.
magnetron. Yeah.
That's another over unity device that we use and we take for granted because it's just so widely used. Nobody thinks, yeah, this thing actually puts out a COP greater than 1. So,
Well, isn't that the way? You know, like you're allowed to have it right in plain sight as long as it's not used for its purpose.
right. Exactly. Yeah. As long as you use it, that's what it's designed for, the purpose of something that's not really going to benefit you in the long run.
Well, listen, people don't tend to ask questions all too much and about how these things work, or even if you told them, they don't really get it anyway. So
Yeah. The
even
average guy
reaching the
just doesn't.
conclusion that that's the case for 99.5% of people out there, is it's an impossibility.
Okay.
Yeah,
Hold
like,
on. I
like
want
that-
to answer this. Do you mind?
Go ahead. Go ahead.
Sorry, I get irritated with this. Do I know how to measure current properly? The answer is yes. You missed the whole point of what I was doing. And this is what I showed you yesterday, Mike, in that video.
Yep.
Where I just wanted to see what was in the cap. Okay. Now, did I want to know the actual line amount of current? I could care less. Do I want to know how much is flowing through the wire at each second? Nope. Could care less. All I want to know is exactly how much is in that cap. And then based on the big spark that I got out of it, I had plenty of current in there. So I know how to measure it the way you guys want to measure it. If I was a lineman working on a house, yes. Do I want to do that in this experiment? No. I just want to know what was in the cap.
Because people don't understand when you discharge the cap like you did and you got that spark and the bang you did, that could have been about 200 amps releasing it in 1 second. Right?
Yeah.
When you discharge the cap, it's all amps, and it could have been as high as 200 amps, which is obviously lethal. So,
Yowza.
Yeah, I wouldn't want to touch it.
yeah, I've discharged a 2800 volt DC capacitor. That's 1 microfarad. But let me tell you, it gives off quite a bit bang, and you can pretty much use it as a welder. So, yeah, it's lethal power there.
Well, look, I'll tell you this. You guys can make up your own mind on what you would think it is, because a lot of people want to disagree and argue. Look, I'll be honest with you, man. I'm showing people how to convert energy. And if you're worried about how I work my meter and you see that spark and you don't get it, just walk away now.
And it's the same thing with
It's only going to get harder.
It's the same thing with the Renegade. They want to know how many volts and amps are coming out of the system. When you're working with negative energy, there is no meter that can read it properly. Our meters are not designed to read negative energy. It's not going to happen. So you have to base this on observation or dumping it into a capacitor bank where you can actually make an actual reading with a proper meter. But if you think you can make a proper reading of the negative energy coming right off your system, you're sadly mistaken. You're never going to get an accurate reading because those meters are not designed to do that.
So what I would have to do is put it into a load and then run my meter after my cap to my load to find out what was in it.
Right. Because it has to be converted into the power potential that our meters are designed to read. And that's it. It's that easy. So yeah, that's the thing with and that's why it's always been labeled as pseudoscience, negative energy, is because we don't have a meter that can register that power properly. Well, let's stop arguing about the situation. Why don't we start designing meters that can read that type of potential, and then we'll have this conversation again.
Well, that's by design, isn't it? Like, isn't that by design? The whole entire idea of it is, you really have a hard time promoting something that you can't find.
Okay, real quick. There you go, Mike. Can you read that?
Yeah. Capacitors release amps right off the battery, but if you cannot get your capacitors charged fast enough to the load, keep the load running. Okay, yep, that's fine. There's nothing wrong with what he said. Yeah, that has to do with cycling the power into the capacitors and keeping it loaded all the time. So if you're working, what I suggest is you start working with a very low capacitance capacitor. So I've got those really big ones. They can hold 2800 volts DC at 1 nanofarad. It's a very small capacitance. So if you balance it out properly with the potential going in and also the amount of potential going out at a certain current rating, you can sustain a light bulb at 140 volts or whatever. You can sustain it. It all has to do with the resistance levels and how much power is actually getting transferred into the capacitor. Because if you pull too much of a load off, of course it's going to crap out on you. The power's going to die off. It's a balancing act with resistance on the load, right?
Yeah. So hold on. My full bridge rectifier is not set up to take in high frequency pulses, right? It's just a standard full bridge rectifier. So number one,
Right.
I'm already slowing down the process. I'm walking through mud at this point. Okay. And I didn't pull a load on it. There is no light on that cap.
Right.
So again, I have no draw. I'm not able to pull it to it, right? The fact that it filled up is absolutely insane. It means I'm forcing energy into it.
Yeah.
Okay.
You're just filling the bucket. Yeah.
Yeah. So the speed in which it gets there, and this is the way I took the question, I'm not filling it up fast enough to make usable energy to run a motor. Well, I didn't set it up to run a motor. I didn't give it the draw. I didn't give it the correct diodes. I didn't do the things that are necessary to drive that motor. So what it does is that as soon as you turn on the motor, it takes the amount in the capacitor and pulls it right away, and I'm not able to refill it fast enough. Well, had I wanted to run it, there'd be a little light in there. There'd be different diodes in there. Then I wouldn't have a problem running it. And then I would change the caps to a lower cap so that it can fill instantaneously and discharge on multiple cap levels, right? Yeah. That's the way to pull your energy. See, but that wasn't the point of the experiment. The entire point was, can I create enough amps and volts to be usable? And the answer was yes.
Yep. So if you were to take that power that was in the capacitor and hook that up to pulse width modulation, now you can control that power and use it efficiently through the capacitor, through the PWM, and to a load. So say like that blue cap that you had there, well, say you had about 15 of those lined up in parallel, and then hook it up to a PWM. As soon as those caps get full, you could turn your PWM on, and probably you'll be able to run a DC motor consistently. Now, it's a matter if you have enough capacitance and enough current coming from your Tesla coil into the cap to sustain that. But that's just all in experimentation. It can be done, and it's totally doable.
Yeah, it's all about the math at that point, just to make it to work.
And
like Tesla, there's got to be a formula for that.
Yeah. Well, Tesla pretty much invented pulse width modulation. He was the first guy, and that was done by the rotary spark gap. So as you spin the rotary spark gap, as you turn it faster, your frequency and your duty cycles increase. When you slow that rotary spark gap down, everything slows down. So yeah, I could say Tesla was the inventor of pulse width modulation. And there's some pretty good plans out there. There's some guys that have actually have some really good rotary spark gaps. That's actually something you should maybe dabble with, Nathan. You might get some interesting stuff happen. And they're not that hard to make.
Well, I'm just worried about the energy I'm creating right now in a spark gap. it may not have the desired effect today that I'm looking for. They have an unusual one. I was telling Joe before you got here, this energy is a lot different than the negative energy we're pulling in the circuits, right?
Yeah.
So in the fact that it's radiant, it goes through everything. Like,
Yeah.
I don't get sparks like you would in an order negative energy system unless it's like this far from it. Other than that, this stuff is just boom. You know what I mean? It's just there. And it's a massive field. You know what I mean? You guys have seen these light up burritos with it. It's just.
Yeah, it's like a gas filling up a room. When you supercharge the electron potential in a given space, it's going to start being fluidic, very much like a gas, and will consume a room. If you have enough potential going there, you could actually fill up an entire room and light up light bulbs on the other side of the room fully lit just by giving it, let it run for about 5-10 minutes to saturate that space. And as soon as that space has been saturated with the active energy, or you could say the heavy side component, now your direct connection with the Tesla coil, maybe 12 feet away from it, because the electrons and all that potential is in a static state. It's moving around. It's fluidic. Anything metal, it'll gravitate to and adhere itself to on the surface. It's like the skin effect to the same degree, right?
Yeah. So there's another question here. Why would I want to use a Tesla coil as a charge capacitor when you can just hook it to the power source? Fair question. Here's the answer. The setup for this device goes beyond the Tesla coil. And we were describing it last night. A can, within a can, within a can, within a field, and Joe and I figured out mineral oil is a fluid field around it would hold it in.
Yeah.
Now I'm compressing the gas like Tesla said, right? Now I'm compressing it, causing more energy. As soon as I trigger it with heat, now I've turned that whole field in there to a very, very hot field that I could shove right into amperage into that thing, right. Which means that now instead of the power source being the better amount, now I'm going to make it 5 to 10 times the amount of the power source.
Right.
That's the conversion. Once I compress, and all those little fields right there are each individual unit, and I simply take one and make a trigger into it, boom, that immediate field right there is a supercharged field. Now I have 10 times the energy.
Yeah.
That's why you would want to do it.
Yeah, that's good. Good analogy of it. Yeah.
Yeah, I mean, isn't that how Gerald does it? But he does it with the geometric double coil.
Oh, no. Gerald is a little bit different. Yes, it would build out like scalar, just like that, right? He's building scalar on an individual plane. So for every winding,
direct outward like that.
Well, no, just flat. Okay, just understand this. For every winding, the two wires go this way, right?
Mm-hmm.
He's getting scalar. So 180 out, he's getting another scalar field.
Mm-hmm.
Because of the way he winds it, he gets a different frequency in each one, which means it has a different frequency and different temperature. So it doesn't add into the one before it. It creates a new one. He does that winding 1,500 to 2,000 times. That means that field that he's putting in there is a monster field, because scalar works on each individual frequency and temperature on each level. As he changes the frequency on each level that he's at, because of the actual winding, he's building layer after layer after layer. So when he puts something down the center of that to pull the energy out, it's a monster number.
Yeah.
I mean, it's unreal what he could do with that thing.
Well, Mr. Unreal should get his ass on the show.
Yeah. I was going to ask you that he's been busy and he hasn't been on at all. He's kind of been dropped off the radar.
Oh, he's, so how do I say this? His wife lost her job and they're trying to compensate for it, so he has to work even harder. So he hasn't had the time to come on and hang out with us
Fair.
to do this. So that's really what's going on. He said it several times. He's shown up in the chat and stuff, and he's just telling everybody he's working real hard. So that's
gotta do what you gotta do.
Yeah, no,
Yeah,
right. You got to
I
pick
think
up.
we'd all be in that situation if it happens.
Absolutely.
I remember I was working several jobs at a time, man, delivering pizzas at night and working during the day when I had that going on. So, yeah.
At one point, I was an Uber driver.
Oh, wow.
Oh, God. Yeah. Yeah, well, that's the bumps in the road in life, right? You know,
Isn't that the way?
well, it goes to show that job security isn't a thing anymore.
No.
You have a job one day and next day you don't have a job.
So, can you turn cold into electricity? No. Cold is the reaction from the electricity making it. You know what I mean? It's one of the reactions. If you're doing it, you're pulling a cold field. It's the reaction, not the process. So
It's the opposite reaction.
yeah. Sorry, I'm going through the question. So
Yeah.
yeah. It's a little bit different than what everybody thinks it is, too. By the way, when I showed that can there, I didn't bother to resonate it, put any frequency idea into it, anything else, right? You know, I was showing Mike the other day, my Tesla coil was creating spinning, voltage coming out of it. I was spraying that stuff, and I had nothing hooked up to it. It was just a coil. So if I put frequency into this whole device with that can, man, it'd start going off the charts because I can create immediate energy out of it.
Yeah, because you got the eddy currents in there because it's aluminum, right? So you're creating a spinning action of that potential inside the can.
Yeah. I don't think people realize that. They know it's a can. They don't realize that it's aluminum right away and what that really means to the process, right?
Yeah.
It's like he just kind of threw it in there.
Plastic coated aluminum at that. Remember that.
Yeah. He's over there. How I say this, with his Mountain Dew and duct tape, creating different things, and we don't really realize that he's actually putting science into it.
That's it.
I find it funny.
All the things have a factor. You know, the flow is just as important as anything else too. So you know, you need to be able to maintain the proper flow, make sure that everything is, you know, going right. That's how she is. And when I heard about the can thing, I was like, oh man, that's just nuts. That's Nathan at work there.
Well, it's kind of a modified gray tube, right? So
Yeah,
that's
really what it was.
Yeah.
Modified gray tube, a little bit of Don Smith in there.
Yeah.
You know what I mean? It just for the fact that it actually built the energy was the cool thing to me. Okay, that was all I was looking for.
Mm-hmm.
Hey, they keep telling me there's no amps in this stuff. Can I create the amps? That's all I was looking for. It's all I cared about. You know what I mean? Can I create something that people said is not there? Well, the answer was yes. And then now, can we make it better and improve it? Yeah. Anybody in their garage can. That's why I did it. You know, it's not a very difficult thing to do, but hopefully it'll help you out in your projects. It's not the direction I was going because, guys, I'm not trying to create over unity here. I know a lot of people think that I really am. I'm not.
Yeah, you're doing good experiments demonstrating what the field does and you know how to confine that field in a space, and using an aluminum can is a good way to do it. I actually never thought of that, and you know, it worked. It shows that you can find that charged energy or that charged gas, whatever way you want to call it, and make, you know, funnel it out and actually fill a cap with it. So very intuitive.
Yeah, that's a little tricky when you're taking, you know, for for lack of a better way to put it. You're taking static or, charged gas or, any type of, low density level fitting energy, and you're able to extract it. That's difficult because usually it just likes to discharge and dissipate.
Yeah. You know how I found it? Let me just tell you how I found it real quick so you guys understand this and how I knew it was there. When I was messing with my Tesla coil and I was putting the rod down the center, I had the 2.5-inch pipe, right? And I usually run a 1/4-inch hollow rod through it. I took a 1/2-inch aluminum rod and put it down there. It immediately went to hot voltage. Did not go to cold, stayed hot, right? So I knew that the geometry played a big part, in the diameters of what I'm doing. So I immediately flipped the field. So you start thinking about it, you go, the smaller one's colder, the bigger one is hot. That means that I'm field flipping, right? So now if I take that same understanding and bring it to the other side, to the finished end of it, now I can field flip the other end because I know it's a possibility, right? Then it's all about creating the flip. You know it's there. Now you just got to create it, right? So we flip flop it, boom, we're done. And we got hot energy now. And the cooler part about it is when I did this on my Tesla coil, I made the bipolar Tesla coil and I put it out, took one side of it, and I went right to the little step stool that was sitting right next to it, right? And I put it there and I got a spark like this, man, running out of this thing. Now that thing's not grounded or nothing. It's just a step stool. So I'm going, okay, I definitely got hot energy because I remember running a DC flyback and getting something that looked exactly the same. And I'm going, okay, I am familiar with that. I know exactly what that's supposed to look like. Now I know I have it. I have a flip. And now I can flip-flop it back and forth and play games with it all I want. And that's how I knew it was there.
Oh, it's a good way to do it. Yeah, that's very cool. And it's not common sense stuff either to figure that. Finding what's not obvious and what's not, the easily detectable is not the simplest thing to do.
Victor Schauberger created a drain case, the extra energy as a pump. Yes, he did. But it's the same way we're making 0-point energy. Victor Schauberger was way ahead of us. He just used the banks of it to understand positive and negative flow on it as he turned the bank. So he already knew he had his, just like that rodent coil around that bank and in, right? He knew he had it. All he had to do overall was charge the outside, and then we create the radius, right? Boom, right in the center. He could float right out to anywhere he wanted. Once he created it, you could put it anywhere you want. So, yeah, Schauberger is a absolute genius in what he did.
All right, so let me be the one to ask the hard question, Nathan. So now that you're where you're at, where do you see this going next for you?
Well, I was just investigating Tesla.
I know.
Right? And I was just trying to, prove out his theory so I could do a nice big video on the whole thing because they did the cold energy. Now I did the resonance. There's still a few things that I wanted to do with Tesla. Some directional energy, some radiant, things like that. And once I'm done with that, I guess we move on. I want to do a pulse motor. And Mike over there, I'm going to be talking to him quite a bit to get this done because I'm going to literally go out and buy a motor that would run a go-kart. And I'm going to make my pulse motor attached to it so that I can pull in all the energy that I want on the negative side of it and recharge and then throw it into gear and slam that, my foot on the gas of a go-kart. So I guess that's kind of where I'm going to go with it. Cool. You know what I mean? Eventually. But I wasn't, as long as I get this thing to be about 90% efficient, that means that I can drive that go-kart all day and I never have to worry about it.
Damn right. It also means that you can make it absurdly powerful too if you wanted to.
Oh yeah. It doesn't have to be over Unity to do that. It just has to be really efficient. So that's kind of one of the directions I wanted to go with it. But you never know. If I get sidelined again and I start reading something about Tesla, I'll start doing another experiment, or you know what I mean? This thing turns out to be a dynamo as you force all that energy in there. You know what I mean?
Yeah.
The one thing that I didn't want to do is show all of the over Unity at once. I wanted people to get out there and learn it themselves. If you show all of it at once, then you get picked up by the police and they, you know what I mean?
Mhm.
You start getting blacklisted.
Yeah, that's true. Well, so far so good, because it looks like everybody that's been discussing this stuff for some time now is generally still intact, which is if anything, we deal with the suppression of it all as far as like being findable and reachable on the platforms. But
Well, that's because they don't bring up the whole cold side of it. So I could talk about this thing 24/7 and they wouldn't come near me if I just talked about the hot side of energy. They'd never care. They wouldn't care once because they knew I didn't have it. Even Mr. Schmuck himself, okay, was telling people that they don't have it right away. As soon as you didn't bring up the cold side or the radiant side, he just told you flat out, you didn't have it.
Yeah.
You don't have it. And he's not being an a-hole. He was being truthful. You don't
Right.
have it. It's literally that way. And people don't realize that because they don't want to define the other side. They want to put it in math terms and then say, I don't know what you're talking about. And that's the way it comes down. They get concerned when you start saying, man, I can light up the ground. You know what I mean? I can take this whole pond and light up. I can move energy through water without a problem. I can restructure the water and make it like veins and run energy through it. You know what I mean? Like my own little conduit. And that's when they start to get worried. They start to go, well, this guy knows too much. That's the one we need to look at. If you just sit out here and tell about UFOs and all the other normal physics it's already out there, they never come near you because you don't have it. You just don't have it. And I don't know any other way to say that, man. You just don't. You can research all you want all day long for every little patent you can find. You can't even make the patents work because you don't understand it. Like, as soon as I look at a patent and I say there's no resistors in it, I start getting worried. I go, okay, they're not running hot energy through this thing.
Mhm.
Let's run it in reverse and find out where it goes, because I bet you they're pulling a cold energy through those circuits. And that's what gets people. They're like, well, how do you know that right away? Because they have no heat in their system.
Yeah, right. Exactly.
They just don't. That I identify right. A lot of coils, no resistors. You're in cold energy. You just don't know how to pull it because you want to run it in hot energy. So you go, man, look at this patent. They got a patent, but they made a mistake and put this wire in the wrong place.
Yeah.
No, you didn't know how to read it. That's what happened.
They're serving raw chicken. They missed a couple of steps.
That's part of the problem. And then you go, okay, so why would there be a lot of coils in it? Well, are they pulling radiant energy? Are they pulling the negative for a reason to put it into that coil to make it cooler for the system? You see, they're not even identifying that. They just go about it and go, oh, man, I can run this thing in hot energy, put all the hot energy. Oh, why is it not amplifying? And then you're like, yeah, dude, go back to school to learn how to cook chicken. Like you said, we're in the wrong place here, buddy.
That's it.
So, yeah, I tell you, every one of them, look at it, you just pull them all day long. This guy, he wrote this diagram, and he said it's over Unity. Okay. Tell me if there's a resistor. I'll tell you if it is. And just keep going down the line. Pull up 50 of them, and then I'll tell you the same thing. Find it. If it's in the system that creates a frequency, you're fine. If it's in the part that's supposed to create the power, as soon as you put the resistor in, you failed. So it's easy to identifiable. And Jack Safardi, I don't even know how to say it. He told that to you guys a long time ago. You decided to hee-haw around and play around in games when he told it to you, and you didn't listen. I took little parts of what he said and cut it in little pieces to listen to it, to get rid of all the miscellaneous garbage of the conversation, right? I don't need any of that. I need specifically what he said, why he said it sucked, why he said they didn't have it. Now I'm going to look at it, right? What was he looking for? He was telling you there was another side of energy and you don't have it. And he said right out, as soon as he saw your patent, you failed. He didn't even look at the math. That's the funny thing. That you could tell by the way he speaks. He never once looked at the math because he didn't need to.
Right.
He looked at one thing and then you ain't got it. We're out. It runs on a different system. And I think it's funny to this day because everybody tells me, you need 1,000,000 volts. You need to crank this thing up the frequency like it's a microwave oven. And then you can get anti-gravity. It's like, well, how do you survive that process? Like, my hot dog doesn't survive that process. How the hell am I supposed to survive it?
By
I mean, how
becoming
does that work?
energy.
Yeah, how does the alien guy come out?
Maybe you stand a chance. Hey, I had something a little off topic that I wanted to bring up. It's a little bit of a theory of mine, and I was talking to Brandon about it the other day. I figured it would make for good conversation anyway. You know, we've talked a million times about like, hey, when or is these sorts of technologies going to be kind of like loosened up, revealed, and distributed, and so on and so forth, right? And everybody's putting forward their best effort here, but I sort of realized something that made me say, it's not going to happen, and not right now, but it will happen, and I'll tell you what my theory is. We have huge oil reserves in this country that are by design. We held on to our oil because we knew that once everybody else was tapped out of oil, we'd be last man standing on it. And we would have all the money coming in from it, and we would have all the use of it. And it would really, act as just a huge protected barrier from us being, unable to operate, in wartime type situations too. So it also added like a layer of security. This is how okay, that the technology is there, developed, and about to be put out at some point, just simply not now. The answer is we're cashing in we're cashing in on our oil. Okay. So, like that's something that you always got to bear in mind. You hear certain things like drill baby drill, that sort of thing. We're going to bring in all this money. Why are we doing that? Why haven't we done it? And why are we doing it now? And the answer is because we damn well know that there's a solution, but it's the same thing as having a store full of products, closing your doors without having a sale. You need to be able to get rid of it, get all your money for it, because if not, it's just wasted wealth. Yeah. So you got to move the oil out, cash in all of that, and then once you're starting to reach like toward midway, end of the line, all of a sudden, bang, mass efficiency, and then oil goes out to all the countries that can't implement that type of infrastructure, and we have it. Everybody else will build to it. And we'll just be raking in the money for it. It's, okay. In my opinion, that's what's going on.
Don't you think there's a reason that there's oil in the earth and that you shouldn't touch it? We just talked about mineral oil stopping radiant fields and the viscosity of it. Well, when you pull tar out of the ground, it basically has the same components in it, and you're doing the same thing. It's blocking something, and when you start pulling it out in California, you might have some trouble because Yosemite over there, Yellowstone, whatever you want to call, you're going to have a lot of problems because you're immediately going to heat it up. And then as soon as you do, we're all screwed. So, yeah, oil's fun, but I wouldn't want to pull it out if I could. Now, I understand.
That does make sense, by the way. I'll throw that out there, but we're doing it. So
no, we are. We're all
we're far down that road.
We strapped into the Ferrari for a fun ride, didn't we? Yeah. Here we go. And I love this comment. I get this every time. Okay. My good friend Todd always tells me this. And I'm going to tell you the same thing I tell him. You are 100% wrong. Okay. Cold
I
energy.
can't read it. Can you read the
just-
comment? I apologize.
Cold energy is just voltage and high frequency.
Yeah, I've heard that. I've heard that shit before. That's not correct.
That's wrong. And, you know, I understand the concepts. You're just creating high RF. It is the concept behind it, right? Well, the problem with it is the field I'm creating is not the same one the radio tower is putting out. And 2 seconds standing right next to me, you'd start to figure that out. And you go, you know, they're walking right up to the radio tower, and until they touch the hot dog to the radio tower itself, it doesn't start sizzling, right? Should tell you something about what's going on. They're not lighting up light bulbs around it, are they? I'm putting this stuff in a freaking burrito and lighting it up because it's different energy. I'm putting it in the ground and lighting it up and lighting up in a 10-foot by 10-foot pond, the whole thing. So just understand this. I'm a completely different energy than what you guys are in high frequency radio frequency. Okay. Now they may have some of the same components in it. That's for sure. But they do not work the same. And
All right, nuanced devil's advocate on that. That radio tower can actually put out these same things, but they're not hooked up that way to do that. But all of the hardware there can realistically be utilized for that purpose. But
you could, if you change it,
Yeah.
but that's the difference
again, I said
between
it's
the field.
nuanced, but you know, yeah,
But
they're not.
how you build it matters, Joe.
How you build it matters. What you put in matters.
See, that's the trick with Tesla. You run this right into a big quartz field, right? You run it into granite, right? That's what he was doing in Colorado. Put it in the granite, wet the granite. You have compressed quartz. You have feldspar in there, which pulls in all the water. Okay, it holds the water next to the compressed quartz. Now you put in the energy. Now you got a massive field.
That's what he was
See-
doing on Long Island too at Wardenclyffe. You know, he just went down into, rather than solid granite, he just went down into highly densely compact, wet, silica sand. Same difference.
Yeah, see, that's kind of the thing here. We're not talking about the same energy. See, you looked at the way it was designed and you told me what it was. You didn't build it and tell me what it was. See, that's kind of the crazy thing. I have a lot of people that do that all the time. They go, oh, we see the components. We know what it is. Okay, well, just put it together then. And I made it real simple, okay? I didn't pull out 500 components here. I bought an off-the-shelf CVS. I bought off-the-shelf capacitors. I wound it really easily, and I put the rod down the center. It was as easy as it can be to build it, okay? I can't make it any easier unless I hand it to you, okay? I didn't buy some cheap Tesla coil off the shelf. I made it, right? But once I did it, I changed the energy, okay? That's what I want people to understand. If you don't do it, you'll think that the same way that I just got told. It's just high frequency. It's the same thing as a radio tower. Good luck with that. It won't build out the same. It won't work the same, and it won't be confined the same way. You know what I mean? That's why I made the distinction earlier between the cold energy circuits and this. We can get over unity with a cold energy circuit. We can create a massive scalar field, one on top of the other. But it's not going to be what you think it is. I learned a long time ago with temperature and frequency and energy, if I can create heat anywhere in the system, I can drive my amps to the roof. If I can create cold in a system, I drive my actual volts way up, right? As soon as it gets colder, my volts go up. As soon as and that means my frequency goes up, my frequency goes down, my amps go up, the heat goes up. It's a direct correlation. So you're only thinking in volts and amps. I'm thinking in heat levels. I'm thinking in creating heat in a confined area as a gas in order to create amps. You see, when you get to a sphere and you want to create level after level after level, you're going to be completely lost because you'll have no idea how to control the heat in the system. I'm controlling the heat in the system 100%. Now, if I want to make Gerald's coil, I can make it flow.
Yeah. All right. All right. Two quick things from
Go ahead.
chat. First off, I don't know if Mike's there, but I know that 8 Center had a question for him about a coiled magnesium plate.
Right here.
Yeah, I'm here. So, coiled magnesium plate. I'm trying to think how that would work. Well, you could use magnesium plate, but how would you coil the wire around that? Well, you could do it similar to the way Laser Saber did it, where he took the graphite rod and then he put the paper towel around the graphite rod, and then you take the strip magnesium and you wrap it around there like that. And then you could probably come up with some other insulator and put a coil around it, but you're not really going to pick up any power that way. The power is going to be going through the graphite rod. So I would have to see that. I would have to look at that a little more deeply.
Yeah, maybe it would be interesting if rather than a graphite rod, it was graphite structured to follow the pattern of the magnesium, the wide magnesium ribbon.
Yeah, see, it's the properties of the graphite is what makes it. You got the differential between the two elements, right? So you could use, say, like Corpus copper. That would work too, but it's a solid piece, like Bandini was doing, with the copper cups, making it into Corpus copper. But yeah, it doesn't really make sense to put a coil there.
Well, hold on. If you wanted more amps out of it, it would. So the wire that comes out of it on the center plate, I believe it is, and it could be the opposite. You tell me. If you put a quick wind in it, okay, and then you hold it together with the zap drops, or you know what I mean?
Yep. Yeah.
Now you're creating a bit of heat. Now you're getting a little more amperage field out of the battery you're putting in, right?
Right.
So you can, milliamps by all means. It's not a very high amount, but it may be the difference between running the motor or not.
Mm.
That's the only way I see a coil makes sense, because you're not going to wrap the whole thing in a coil. It's a battery. You pull the energy out, and then you could transfer it into a coil, but that would just be using the energy because it's coming out hot.
Yeah.
So you just a little bit gives you a little bit of heat in there, which gives you a little bit more amperage without losing a bunch of loss in hysteresis, right?
Well, you're getting quite a bit of current from just the magnesium and the graphite alone. You could get up, Laser Saber got his 2 cells up to 2 amps. So that's 1 amp per cell. That's not bad. That's a decent amount of current coming out.
No, I agree with you. That's pretty good.
Yeah.
Maybe you don't need that. Yeah.
So to me, you can experiment with it. I don't think you're really going to get that much more of a gain out of it. Now, the whole point is taking that power and pulsing it. Then you can make more gains on it. Sure.
What if you play devil's advocate here? What if I just took a battery and I took out all the acid out of it, cleaned it out, and then I put water in there with the what was that stuff? Pickler stuff?
Oh, the alum.
Alum. Put it in there with the alum. Would I now have a battery that produced a lot more?
Yeah, well, it does. Well, Bandini was doing that with a partner of his. They were working on that. So they were taking, batteries that have been sitting for quite a while. They'll dump all the battery acid out of it, clean it up, and then they would make their mixture of alum, pour it into each one of the ports of the battery, and then they would have a battery running. And it turned out that they weren't getting 12 volts. They were getting close to it, about 11 and a quarter volts coming out of the battery, but now you got a potential of having a battery last 20 years.
Mm.
Right?
Well,
Because
just design our systems to go under 12 volts would be all right.
well, because you're using the water and the alum, there's no galvanic action happening anymore. So the lead plates are going to last now. They won't corrode. Same with the magnesium. That was the whole point of using the alum. The alum and the water allowed the electron flow from the magnesium into the system without a galvanic action. There is no galvanic action, and that's the whole point. And a lot of people miss that. So that's the reason for that type of a crystal cell, right?
Hey, Mike, do you have to condition these things? So you got it basically right out of the gate, the energy. But if you condition them like you would, like, say, salt water for a battery, you have to condition it, charge it, and decharge it. You know what I mean?
Yeah. You don't want to put any kind of salt or any kind of corrosive at all in the alum. You just destroyed the whole purpose of it.
No, that's not what I was saying. I'm saying, do you have to charge the battery, then let it discharge, then charge it
I see what
again?
you're saying. You could. Bendini did it with the big car batteries. Yes, put a small charge on it for a little while, and after that one charge, that's it. You don't do it anymore.
Right, you're conditioning the battery, right?
Yeah.
See, they do it with salt water. A lot of people don't understand that when they do saltwater batteries, they have to condition it a little bit in order to keep continuously getting charge in it.
Right.
It's basically programming.
Yeah. But then again, you know, when you get corrosives in there, now you got a galvanic type battery. So the whole point of the alum battery is the fact that it's not a galvanic type battery.
Right. So it's like not sacrificial in terms of
right. So where a magnesium, if it is in a galvanic mixture, it's not going to last very long. It's going to burn up very quick. It's going to corrode and oxidize and deteriorate a lot faster. So with the alum, that's not happening now. So now your magnesium could last years.
You know, I had a question, and it may not be about this battery, but just in general, when they do water in there, when you put a little bit of voltage in water, it creates lines of force in it. And I just mean it finds a pathway to the next end, right?
Mm-hmm.
And then now it'll keep repeating the pattern once you did it. So is that all he's doing when he's sitting there and he puts a little bit of charge into it? It's creating the pathway. Yeah. Now it knows where to run, and then now all you're doing from there on in is it makes the same easy pathway every time.
That's right. Yeah, it's like creating lattice structure, and that's what the alum does when it crystallizes, and that power is going through the crystallization. It's creating its path. Now the path has been created. Every time you add water to it, now that potential knows where to go through the lattice structure of the crystal.
Yeah, makes it easier.
Yes,
that's how the brain works too, and you know that's how you could create new neural pathways and things of that nature just by expanding the amount that discharges. Tries to keeps the same paths, finds new ones, and then keeps the new ones.
You know,
that the same paths.
It makes a lot of sense. Okay, let's think about it this way: you put on a crown, and the crown creates different magnetic values in different places. It means it's creating new pathways in your brain. It's driving it, forcing it into a different direction than it was before.
What, like narcissistic tyrannical pathways?
Well, I hope not.
Yeah, then we got problems if that's like that.
Got to avoid those.
Yeah.
No, what I'm saying is that
it's creating like a neural network. That's what it is. Yeah.
By getting in there,
sending it from prong to prong too, you know.
So as soon as you access the body, it might be expanding your pathways in your brain. Oh, isn't that freaky?
Hopefully the pathways are in the right direction.
Yeah.
Now I know Brandon said something earlier that I wanted to touch on too. So he was talking about you have a good metal detector, you pass it over granite. Your metal detector will more or less go haywire. I metal detect, and as you know, I like rocks. So there's some truth to that. It's not wrong. There's like hot rocks, obviously granitic, deposits and stuff like that. There's a lot of different elements that could potentially settle in, different inclusions that could exist within and whatnot. But more times than not, the reason that it won't actually set off even a good metal detector is just because even though you have metals that are, within that granitic structure, it's ionized in a crystal lattice. And those ions just aren't enough because they're not in their own form crystal lattice of their elemental, to have their elemental properties enough to be detectable. So, for instance, hematite is iron in quartz. Often turns it red or silvery depending on what the composition looks like. More times than not, it's not detectable because of that reason that I just said. When you have exceptions to the rules, when you have like magnetite deposits and stuff within the granitic structure, which happens commonly, and if it's at high enough of a distribution within a rock, you will overload a metal detector. You get big OL on the screen and it give you a really annoying sound. But more times than not, like if you're metal detecting and it's happened to me so many times, you dig up and all you find in the hole is a big old rock. It's more times than not like what they call like a hot rock, which is either laced with like actual iron, elemental iron in it, or has high degrees of magnetite. Even sometimes it's just like a chunk of magnetite, which is kind of cool. But yeah, that's sort of that. I mean, the detectability of like ionized elemental metal that would generally be detectable by a metal detector doesn't actually pick up like you think it might. So I wanted to address that. And he also said something about a mine lab. I liked White's metal detectors. They went out of business. And have a couple of them. One day I'll pick up a mine lab though, because they're good. So yeah, that's that.
Go out searching for rocks now.
Those aren't the rocks I want to really find though. They're not that they're interesting, but not that interesting. So
Wow. Yeah, I was telling Mike we were talking about that about his battery. I'd like it just to turn on the light, you know what I mean, over by the wife's little planter, and just spray it in the morning, you know what I mean, get the water into the system, and then let them light up the lights all night, you know what I mean. So I want to try that out because I just think it would cool to trip her out, you know what I mean. She'd be looking out there going, why are my lights on? There's no batteries. That'd be awesome.
Yep. Yeah. Yeah, they're definitely fun to experiment with.
Yeah, free lighting, passive heating. I was asked the question, so is the Tesla Coil a cold energy device? Normally, I would tell you no, if you just deal with the outside of the field. But if you deal the rod down the center, then it absolutely is. It's more of a radiant energy is the way I would describe it. But it's on the negative side. So that's probably the proper way because Tesla keeps describing it in that way. So I don't want to go against him in that because he probably knew a little bit more than what I was thinking because he had different uses for it, especially when he made his X-ray machine in negative, energy. He wasn't doing with the outside field of the Tesla coil. I can tell you that. He took that hairpin circuit and he made it. So if that tells you anything, man, he was definitely in cold electricity when he made that one. And that was safe. And I can tell you everything about this energy so far. It's not like the hot energy of the outside of your Tesla coil, which is really destructive to you. It's really a very good thing to be around. Okay. I've been having so many troubles after I created this thing over here with this can, and my hands just arthritis all over the place again. You know what I mean? Because it's creating hot energy again. I need to go back to the cold energy so my hands can be free again. I can't wait. You know what I mean? But it's just not right. So yeah, he definitely that rod down the center. It's just a different geometry than the hairpin circuit.
Yeah, cold energy will never hurt you, where the hot energy will hurt you.
Yeah.
Pretty much.
We could get into detail in that, but we can't do that on this platform.
Yeah, I
Keep
don't want
on
to
saying that there's got to be a Rumble stream on that, but I really think that we ought to do that.
Yeah, well, wait for Gerald to get back.
That's fair.
Because he probably knows more about it than every one of us combined. And yeah, I mean, he runs this cold energy into his plants. So he understands growth rate and stuff like that, which is really something interesting to get into. They did plants on a plasma channel on how to grow it with plasma, is what he said on the thing.
Yep.
If he only understood. It's grounding out the energy when it takes the frequency and allows it the frequency alone to go into the plant. Once you have the frequency of the plant itself, then it grows faster. You're gonna change the whole system of that. So
if you take a barium ferrite ring magnet and put it on the soil where the plant is germinating, it'll germinate quicker.
Oh, it'll build faster too. It'll grow faster.
It does. I've already proved it myself.
Yeah.
My daughter had this little plant that her grandma gave her, and I decided, I got this ferrite magnet, the ring magnet. So I put it in the plant, and man, did that sucker take off. Did it ever?
Yeah. as per usual, Ape Center saying, Organite had fixed you up, Nathan. I mean, yeah, I tend to agree. I mean, that's exactly what you need. When I was talking last week about some of the Organite cells that I was planning on, I had given a little more thought to like how I'm going to go about it. And, I don't have them readily available, but I sketched up a couple of designs on my phone of what I wanted to do. And I came up with this idea too, although I don't know how I'm going to pull it off just yet, but I'll get like a post hole digger and dig like, kind of as far down as I could reasonably get. And when I'm setting the Organite, I was thinking about actually lowering the mold down into the ground and just having it set, under earth. That way, it picks up all the resonance of the immediate area. It's almost like custom tuned to the area's resonance at that point. So that was something I was contemplating as well. Goes right hand in hand with what we were talking about with Jarvis last week when it came to, setting crystal structure under high voltage or frequency resonance.
Organite, which is that a crystal structure?
Mm-mm. Organite's the man-made compounds that we've talked about a few times, where you're more or less layering organics and non-organics, alternating with piezo's, and then also copper to keep copper coils and stuff to keep the flow. It's all bound in a resin, so the resin keeps the piezoelectrics under pressure when it sets because it shrinks. So you more or less have all these alternating layers of fine ground metals, along with the sands and different organics. And, it's just basically it's also it's kind of sort of like the idea of it's sort of like a standalone transducer, more or less. I know some people build them, with input abilities to the coils that they put into the resin structures, where you could hook it up to an audio source and run specific frequencies through it as well. So there's a bunch of different uses, but you don't have to have that. It just kind of works standalone. Yeah.
It's interesting.
Yeah, it's definitely. Like I said, I definitely wanted to cover that one time. I've been meaning to get with Eighth Center to kind of get more of his take on it because he really has some cool stuff that he showed me and whatnot. So I wanted to get that whole side of it and then combine that with what I know to bring it to a nice presentation because it's super cool stuff. And I think that actually all of the most advanced technology that's going to come out of these concepts that you're proving day in, day out is going to end up being very, very similar to what orgonites are already. It's just a matter of structuring it the right way and having it, I really think that that's where this is ultimately going. All of it.
Well, I've always considered this type of energy to be like Earth energy. So
Yep.
it's going to build out the same way. And yeah, I'm looking forward to the crystal thing. I'm almost done with what I'm doing here, Joe. And for those of you who don't know, I got some different salts, some Epsom salts and stuff. And we're going to grow out some crystals and make some plates and put some that aluminum tape on there down on the bottom so that we have a place we can clip clips to. But I wanted to add frequency into it. I wanted to use just regular straight 9-volt battery or something as we built it. So it'd have a hot energy in it. And we may go down to 3 volts if it doesn't structure. I also wanted to use the 1-wire energy, but I want to put it in a radiant field. So as it's in the beaker, I want to put the coil on the outside of it and run it in the coil so that it goes in there. And then the last thing would be just to dip, the wires straight into it and see if it picks it up. I guess the goal is here, can we build the crystal and can we impart our own frequency into the crystal? And then once we do, how is that frequency going to make it react to the crystal? Will it shatter it? Will it move it? Will it do nothing to it? You know what I mean?
Yeah.
If it imparts the frequency and we can put the crystal back in water and we get a frequency out of it because there's energy into it, then all we need to do is match that same frequency in order to do it. And I got a frequency generator. We could just throw it in there. You know what I mean?
Yeah.
But I think that would be pretty interesting because what was that material that one guy was using? That was not quartz, but it looked like quartz. It was just the one that kind of breaks off real easy.
Calcite?
Calcite. I have some of that.
Or
Calcite
selenite?
crystal. Yeah.
So it puts off energy. So it must put off a frequency. So I was curious to see if I can put my oscilloscope over there to it while it was putting off the energy and just check it to see what the frequency was. And then if I simply put my frequency generator to that same frequency and amplify it, would it do anything to that calcite? You know what I mean? Can we get it to move? Can we get it? You know what I mean? Because it might help out and answer and build out the profile and this stuff as well.
Yeah.
Yeah, calcite's definitely something you want to play with. I have quite a bit of it.
Yeah, nothing really ever really interests me as much as quartz. But I mean, I've been bringing it up, and frankly, I just don't know enough about how it works in these same things. But I keep on thinking that the 6-sided crystalline structure of sapphire is probably immaterially superior to, the 5 sided quartz structure. It's just kind of my takeaway on it, because especially of how it builds up in its crystalline form in alternating sets of 3. So it makes 6 by basically having a rotational triangle, in its formation. Now, how that ultimately forms when you input frequency into it, I'd be really interested to know. And I mean, making it is not all that complicated, although it's not simple. It's just not that complicated. It can be done.
I have a distinct feeling the frequency determines the shape. And we get that because we're taking coils and making the shape and making the frequency. So I think it's vice versa, you know what I mean? It goes both ways. I honestly think It has everything to do with the frequency that makes that shape while it's building. And
Yeah.
it just structures things. And if we could prove that out, man, that'd be massive. So,
Be really cool to know. I mean, it even goes further than that. I mean, depending on how you're sourcing your, the elemental matter that you're building. I mean, if it's through a process like ionization, I mean, you could probably expect great deals of transmutation to occur, under those different resonances too, because you're dealing with the sub portions at that point. You're dealing more with like prima materia, so to speak, than you are something that's set as an element or compound to begin with.
yeah. I want to answer this real quick. What is cold energy? It's just the inversion of a field. You're taking your dielectric and you're moving it inside your magnetic. If you look at Steinmetz, the way he describes it, that's it. Taking my dielectric field that's on the outside, moving it inside to my magnetic field. That's basically all cold energy is. And by doing that, it creates different effects. Keeps things colder, gets rid of Lenz's law. There's a lot of cool effects to it. It also allows you to get to the 0 point field. So cold electricity is just that's as simple as I can make it for everybody. You can make it overly complicated and start talking about electrons and how they build and how many more there are. The simplest way to say it is I got a field here of magnetic energy. I'm taking my dielectric, I'm moving it inside, and that's it. It still builds the same way. Energy still builds on it, still works, pretty much the same way. But the laws that are associated with magnetism change. That's it. It's as simple as I can make it.
Elias says that we need a party science room, so maybe we'll rent a Chuck E. Cheese in the middle of the country one time.
Oh my God, dude. If all of us got together with our inventions, that would be we might light up the whole state.
Yeah, we could all go there, play with the Tesla coils and eat shitty pizza and go home with the flu.
Oh, can you imagine that?
Yep. Next meeting Wednesday night at Chuck E. Cheese.
That's right. They have alcohol there, so you might maybe get to see like a couple parents fist fighting. Have you ever see those videos on YouTube? Parents get tanked at Chuck E. Cheese and they end up fighting.
Oh my God.
Oh,
That place sucks so bad. I used to hate thinking about kids. Anyway.
Oh man, I'm gonna make me Sean's coil too. I'm gonna have to take the time to do it. I want to see that inverted field. You know why? Help me out, Joe. The one that looks like a rock, but it's purple on the inside, the crystal.
Amethyst.
Okay. He did a demonstration with that coil. He literally pulled the energy into it. It literally attacked it. Now, I don't know if you know anything about crystals and stuff, but when you put it in there and people show you electricity experiments, like, hey, I'm making it light up, right? No, what they do is they create a spark that goes around it, and then the light travels through it, so it looks like it lights up, but it's not. Okay? Sean literally put this thing right here, and the energy, it just went, it doesn't like anything. Remember, it didn't like anything. It wasn't touching anything. It went whoop, straight to it. And I wanted to see in that if he actually got it to light up. That was the most curious thing about it. The energy, in order for that energy to like that so much, it had to be the similar type energy. It had to understand each other in some way that we didn't, right? So if it's the same energy and we can prove that out, we know the crystal that's creating the energy of the earth, right? Because he's literally taking its ground line and putting it in there. It goes through its number 2 coil all the way up, and then shoots out the top. So he's changing the frequency, but he's also, just pushing it out the top. So it's like, boom, right to it. And it was like, okay, this is something completely different. I've never seen that reaction in my life, and I want to exploit that reaction. I mean, it's one of those things that, as you're sitting in your lab, you go, oh, I'm going to put that to the side because I have to explore that. Pulled that one. Yeah, that was just one of those crazy things. It's like his ground. He turns this thing on, and the ground starts shooting electricity to it, pumping it right out of the ground. The only thing that does that is lightning.
Well, the thing about that too, with the electric jumping to the crystal, at the end of the day, an amethyst geode is 100% quartz. So, whenever you're going to stimulate it with that type of current, you're also going to get an amplification effect off the piezoelectric in the first place. So, yeah.
Yeah, but if it lights up, man, there was something to that.
Oh, definitely. Well, I mean, cold electricity is a thing. Cold light, rather. I don't know what I'm saying. Cold light.
Well, the only time that I've ever seen that something that wants to pull out the energy from the earth into like a Tesla coil, right? It would be the same thing as lightning. When you see the little tendrils coming up from the ground as soon as lightning goes, and then they hit, you know what I mean? It's the same thing.
That goes right with someone in the chat said, hang on, who was it? Felix, right, said about cold electricity helping plants grow, right? So the tendrils coming out of the earth, that's earth energy, and it's just making the connection with the lightning that's coming down. So, when you even were to take a coil, and it goes right back to the orgonite, like we were talking about earlier. When you take a coil, for instance, and you put it into the ground, with a plant or a seedling or something like that growing on top of it, that coil is actually now within the ground, and it's able to act as an accumulation for cold earth energy. And if it's geometric and it's spiraling and stuff, ultimately it does create a very light field. It creates a light field, and this is good for plant growth. Like
they make them like a little tornado going down, right?
Yeah, pretty much like a cone.
Yeah,
and that's exactly what it's doing. It's just acting as a non-organic within an organic that is an accumulator of the earth energy, and then the geometry of it gives it some semblance of a flow, and then anything in the immediate area would be a benefactor of that.
That's cool.
So yeah.
I always wondered why they did that. I seen it on the Facebook because people talk about the thing. I never read the article. So that's pretty interesting.
I mean, it's no different. It's just, it's using what's already there as opposed to putting more into what's there. So like when you were saying before that it helps plant growth from the cold energy side, I mean, that's amplified, and it's more present, and it's also not native. It's being introduced, but it's already there. So it's similar in circumstance. You just don't necessarily need an output because, again, you have an inorganic and an organic in layers, the same way, kind of same as an organite in layers because of the spiral. Yeah.
It's interesting. So let's see what it says. Giza Pyramid. It's what they were doing. Pulling the energy in. I can see that they're pulling the energy in. I always think it's down. I never think it's up. They always show the shooting light.
Mm-hmm.
I'm out of that picture, man. I always think it's pulling down. So
I kind of see it outward, to be real.
I can see it going outward.
Outward.
But they direct it to a point at the top. So if they direct it to a point at the top, I see it pulling down. But if you're talking about just an antenna array, it's like a radiant energy, yeah.
Well, that's the thing about anything, even pardon me, even like quasi cone shaped. Things naturally want to accumulate toward the tip of a cone. So, regardless, it's just always sort of the way. So whenever you think about flow and propagation, generally you do look to the tip, but at the same time, what was it doing? Because there's an internal geometry to the pyramids as well. So when you look at the external geometry, that's not necessarily it. It's what's inside too that ultimately is the cause of the effect. Pyramid shapes in themselves have certain properties that directly coincide with energy accumulation within them, and being able to hold and also naturally compress those fields as well, just through the geometry of a pyramid in itself. But then when you look at the inside of the pyramid, that's really where the magic is happening. It's not so much on the outside, it's the inside.
Oh yeah. So you saw that what is it, the main chamber where they have the different sizes? They go like that and they step down. When they do that kind of stuff, we're talking about harmonics here. Okay.
Mm-hmm.
And the frequency wave only builds in a certain size. You know what I mean? That's what they're messing with there. That's exactly what they're messing with there. And then when they create that same harmonic by taking that big thing that goes down at the very top, it'll open and close the door. They're opening and closing it in order to change the harmonic of the actual pyramid. So when they do that, it changes which one it goes into and where it resonates at in that pyramid.
Absolutely. Okay. And, I do want to clarify one thing, because 8th Center said it's actually both. Yeah, I was trying to, that's absolutely correct. It's both. I was just trying to say it's not only the outside. So I kind of misspoke on that a little bit. But what Nathan's saying, that's the case. This is natural amplification. It's a tap to an earthquake. That's really what it is. It's a whisper to a scream. That's what that geometry does. So if you're creating a little bit of energy, it's amplifying that energy. If it's a little bit of vibration and resonance, it's a lot of vibration and resonance. Mm-hmm. And it emanates outward. And then when you look at the placement of it and then the structures of everything around it, we've talked about it 1,000 times. That's not the only thing the pyramids did. It's one of the many things that the pyramids could have potentially been doing. Mm-hmm. Could have been doing it all at the same time, or it could be possibly, set up into modes where it could be doing certain things at certain times, and it's just depending. I mean, I think that it's obviously one of the great mysteries of the Earth, even though we're getting probably closer and closer to figuring it out. But what I don't understand is how scaled models of this stuff hasn't been done and tested more thoroughly, and then with that information out there, because it's not like they haven't modeled these things, but I've never seen them actually do anything really with it.
Well, I can tell you why, because they don't understand the process. If I didn't tell you there was harmonics in it, right, and if you didn't know that, you would just think, well, let me just put it as close as I can to whatever, to make it look that way, right? But you're not looking at the exact distance for the harmonic. See, that's the whole thing with the thunderstorm generator. It runs on harmonics.
100% does, and differentials. It's differentials, but yeah, that coincides directly with harmonics anyway.
He literally built the length of it, between the two spheres as a harmonic. He then built each layer of the circular spheres. Each one of them is a certain distance apart because of the length of the harmonic. Okay, so then now he knows if he's in the first, second, third, or fourth harmonic. He knows which octave it is. He knows which frequency he's trying to create, and in that he's creating ball lightning in it. Mm-hmm. That should tell you something about it. The rest of the other side of that whole thing is a bubbler. It basically makes foam. That's what it's doing. It's bubbling and making foam, and he's using a light bulb in order to ionize it, in order to make the foam a little easier. He's putting it through several different things so he can chop down the big bubbles and just create the tiny bubbles. Then he's bringing it in there. Now, what happens in the harmonic? Okay, here's the funnest part about this. You put something in your harmonic water, right? And it cleans parts. That's what it does. So you take these, I want to say little piezos, you put them on the side, and all they're doing is creating vibration. And in that vibration, they're cleaning the parts, right? Well, you're not cleaning parts in this thing. What are the harmonics doing in there? They're breaking apart the structure. So if it's H2O, you're breaking apart hydrogen and oxygen. Now, what does it do? It goes over to the thing that you're inputting into it. Say it's smog or whatever it is, right? It's breaking those. Now, when they get to the other side, they're recombining them. Now it comes out as something different, so it's clean. Now it's a different structure that comes out of it. He is literally showing you how to break it apart and put it back together with harmonics.
Well, now if you think about like star in the jar stuff, I'm gonna like coin a phrase, I guess, at the moment, but it's like intramedium equilibrium, which is super fascinating to think about, because whenever you have things that are two separate mediums and densities, generally speaking, you have separation of the two, right? You know this. It's common sense.
Mm-hmm.
But what happens when you have it in equilibrium and in a state of suspension? That's mind-blowing stuff. And frankly, I mean, that's to a degree what like the bubbler foam generation of the cavitation chamber in the thunderstorm generator is exploiting. But it's such a good visual representation of what's going on there, because you're creating an equilibrium of two things that are not equal through resonance, that are in a state of expansion and contraction continuously. But they only stay in states of equilibrium for brief seconds, like probably like Planck's, the time, scale, like for that brief second of equilibrium. But that's all you need for massive amounts of generation. That's the thing. You only need these two unequal things to be in equilibrium for incredibly small amounts of time, repeatedly, for massive generation.
Yeah, I agree. But it's so interesting because they use the exact same thing in the water car. The only difference is he was able to pull the oxygen to the side because he understood the magnetic and harmonic value of the oxygen itself, and it pulled it away from the hydrogen. So it would allow the hydrogen to all come out while the oxygen stayed there. That's what was so cool about some of this stuff. It's all almost the same technology when you go through it. It's just about how you build it. That's what was hilarious about it. I'm reading this thing, right? And I'm going over it yesterday, and I'm going, well, okay, I know that. Well, why didn't we know that already? You know what I mean? Because it was all the same processes. It was just what he was specifically looking for is what he tuned it to.
Yeah. No. Okay. So wait. What? Okay. Anthony. He says about Viktor Kurbenikov. I mean, in my opinion, right? This is like one thing that is super underutilized is cavernous material effect. Because that is the pyramid in fractal form. You have to understand that what's going on in the interior of the pyramid when it comes to resonance is happening at almost, or actually probably a microscopic scale, just over and over again, right next to each other in high density throughout the entirety of a piece of material. When you bring these types of independently held resonance fields that into environments with like normalized equilibrium and density, it just screws with it all. You bring enough of this material into one place at one time, and the interactions are out of control. the geometry of the way that they lay these patterns down is all super significant because it's going on a microscopic level that's also macroscopically and objectively observable, and in forms of interaction with all the other pieces similar to it, because like a magnet that has poles, when you bring two magnets together, they interact with each other, right? And this is similar in that circumstance, just not magnetically. We're talking about field flow at that point, that because they have their own field flows.
Well, that thunderstorm generator is showing you transmutation, and you start with one element, you end with another element, right? It's showing you how it works, how it pulls things apart and puts them back together. You know what I mean? We're not dealing with an organism here. You know what I mean? We're dealing with the basic structures of things. Pull them apart, put them back together in a different way. Completely different structure. So we may need to add harmonics to what we do with the crystal in order to do it the right way.
Yeah.
You know what I mean? It's a very big clue right there.
Well, I don't know about like in order to do it the right way, but to have more control over it.
Yeah.
To have more
There you
control over it. That's sort of what it is. I mean, thunderstorm generator does it in a fascinating way because because it's burning fossil fuels, it's really dealing with high amounts of hydrocarbons, and hydrocarbons are pretty much the building blocks of everything. Hydrogen, friggin' carbon. Once you separate that, and more or less you could make anything out of it. It's building blocks.
Well, it's also an energy generating machine.
Yeah.
That a lot of people don't realize this. They understand the smog aspect and the cleaning of the air, stuff like that, right? That thing is actually an energy generating machine. And you go, okay, well, then let's look at the basics of it. If it's based on harmonics, what does that tell you about your winding your coil? What does that tell you about your patterns in your coil? If they're telling you that transmutation happens in harmonics, then what does it tell you about what you're doing? You know what I mean? You should really start to think about those type of things when you're building this stuff. There's really more to it here. Like if you're seeing actual examples of very specifically, that's what that machine is. There's no getting around it. That's what it is.
Absolutely.
Now apply that same understanding to something else. Now I'm building a geometry coil and I want to add harmonics to it. I better know the frequency of each layer, and I better understand what the harmonics are. I better understand exactly how the energy should flow to build that, right? It tells you why you have a transmutation in the coil itself. That Joe, every time I learn something, it goes back to Gerald's coil because I know darn well he's got it. You know what I mean? Every time I turn around, I see something else and I figure it out and I go, oh my God, it's right in front of me. It is literally right in front of me what he did. You know what I mean? And it trips me out to no end to know that he's smart enough to put every single part of that whole thing together in that exact way. Just trips me out.
Yeah.
Sorry. Hey.
Yeah. Okay, hold on. So Brandon's saying that I don't let him on the show.
He's been trying all day to get us to play that song.
I know.
Which one is it? Is it the new one we just?
The one that you liked, I guess. Yeah, I mean that's the only one that I made and sent you. I mean,
well, let me look for Brandon.
That is a collaborative effort, by the way, between Brandon and I. He made a song, then I made a variation of it.
Okay. All right. So you ready?
Sure.
Let's bring it up.
This one's for you, Brandon.
To make sure the volume's up on this thing. Yep. Okay.
Fuck about that side. Yeah. Fuck about the side. Yeah. Yeah, old man built, Nate's out in the dark. Full moon hits, bare grit, leave a mark. Fireballs ripping, probes cut through the air. Gravity killer, no time to care. Dolomite grind, dirt under his nails. Breaking physics, tipping the scales. Out in the wreckage, forging his rain, turning rust to rage, rewriting the game. Yeah, Faraday's quiet, bound up, NDA choked. Big B sees through it, plan stay stoked. Cells locked down, but we know the code. We hustle in the dirt while the truth corrodes. Mike, respect, yeah, you paved the way. But Big B's breaking locks, we don't play. Corporate chains won't stop this crew. We're flipping the scraps, making it new. Yeah. Sean's a shark thrift king with the blade. Deals in the shadows, carving his trade. Plasma Lord, sparks like art, reviving dead tech, tearing it apart. Benny shows up, lab coat in black, knows his worth, charging stacks. But grind harder, Benny, don't backslide. Energy's priceless, hustle with pride. Joe spits fire, wisdom's raw, words cut deep, leave you in awe. Talks that woo-woo, but it's razor sharp. He's the truth, wrapped in chaos and heart. Rambling genius, coded lines. Catch the spark between his rhymes. Think he's joking? Look again. Joe's got the edge to shake the zen. Jarvis reigns where the static thrives. Voltage king where the real ones survive. Circuits sing, his crown's the hum. But when it falters, you know who comes. Big B steps in, amps to the skies. Tweaking the chaos, making it rise. I'm not here to claim, just to ignite the charge, the surge, the endless fight. Gerald's locked tight, secrets and chains, building in silence, rewiring the game. Gems in the shadows, waiting to drop. When he unleashes, the world won't stop. Big B steps in, amps to the skies, tweaking the chaos, making it rise. I'm not here to claim, just to ignite the charge, the surge, the endless fight. Gerald's locked tight, secrets and chains, building in silence, rewiring the game. Gems in the shadows, waiting to drop. When he unleashes, the world won't stop. The Big B keeps watch, back in the grind, ensuring the edge stays sharp and refined. Hands on scrap, I mold the grime, turning rubble into a lifeline. From junkyard dust to cosmic streams, Big B's the architect of these dreams. The rhythm, the pulse, the spine of the team, the god of grit in this energy scene. I don't take, I spark and provide, keeping this machine alive. Woo! Free energy's free, but the grind ain't cheap. We build with the broken, digging deep. Turn the waste into power, make it burn. This revolution's ours, it's our turn. Nate with his grit, ass out in the grind. Sean and Benny carving new lines. Joe's raw truths, Jarvis in the flow. Gerald's secrets ready to blow. Faraday's legacy wrapped in red tape. Big B smashing through, shaping the shape.
Oh,
Nope.
what is-
I guess that's that.
I don't know what happened there, but that didn't sound right.
No, me either. But then again, that's what you get sometimes when, you know.
That was good.
Yeah, man.
I like that one.
Yeah, that was fun.
Better
Yeah.
like the other version of it.
Ah, well, you know what? Next time.
So, hey, for those of you out there, guys, on the emoji thing, we got Sean's emoji unlocked. We got our 20th member, and I'm going to throw it up again. We got Sean out there, man.
That's awesome. Do you know
So-
who our 20th member was?
Give me 1 second. I will pull it up.
Give him a little shout out. Got a new emoji. Thank you, Paul. Always kind,
Yeah.
man.
Guy 9021.
Well, thank you, Guy. Appreciate you, man.
And we also got another one. We got a 21st member, Maxolous, Maxolus.
Very cool.
So, yeah, pretty cool, man. It's just so awesome. I love it when they throw up the emojis in the chat, having fun. You know what I mean? I know
That's
you
fun.
usually just talk about science, but I can't help it, man. If I get in the chat, dude, I'm all over that.
Yeah, no, I know. And you know, once I leave this show and I'm in the chat, I never talk about science. I've been
Yeah.
quiet lately though, so I apologize. Hey, it's Sean. What's going on, man?
Sean, he's feeling better. Thank God, man. He had some rough times here lately, and I'm glad to see him.
Yeah, it's awesome. Yeah, definitely hope you're feeling better, man.
Yeah, Sean, I'm gonna throw it up for you, buddy. There you go.
Yeah, and yeah, give another shout out to Sunny. They're new.
Yeah,
You know, she doesn't know who's yet. You'll catch on. Come back. I'm straight dope. You know, when I'm not on the show, I guess. And Sean is Sean, and Brandon is Cody. You'll figure it out.
yeah.
Same people.
I'm the old man builds.
That's it.
So yeah, man. Oh, that's so cool. I really enjoy that. So Mars colony. Ooh, there's always a fun subject. Let's not let Elon Musk take action on nuclear missiles to Mars, huh? Let's some of the stuff I hear, man, I hope that's just a stupid rumor.
Yeah, listen, this shit's out of our control. No sense worrying about it.
Well, they found like an underground lake in there, and they say it's all in the rock. All the water's inside the rock, which matches what we have here on Earth, right?
Pretty
There's
much.
a huge ocean underneath the ocean in the rock. You know, they don't have any tidal force. So we have a moon out there that pulls this stuff in, right? And pulls out the tidal. Well, it would pull the water right out of the rock and make it a livable planet if they could just take the two moons they have and combine them, which I'm sure is a bigger feat than I make it sound like right now.
Yeah,
But
you're making it sound rather easy. Plus,
yeah,
I mean, what at the end of the day, we know what matter and proximity with other matter, you know, is like, and what doing that would ultimately do to everything is, you know, probably probably disastrous. Frankly, it'd change all the orbits and stuff. It'd be a mess.
I mean, look, if we get up into space, let's be honest with each other, we're going to be mining, you know, rocks out there in space, asteroids. It's going to be the time where it's like those things won't be out of the question.
Yeah, why mine Mars when you could just mine Greenland?
Because I would like another planet in case this one starts going to hell in a handbasket.
Start?
Yeah, I would like to get on my UFO and go to another planet and visit for a while.
Yeah, man, you're not kidding. So, did you hear about this AI infrastructure bill
Right there.
situation?
Tim's
cool.
awesome, by the way. I just wanted to give a shout out. Hey, how you doing? Go ahead.
Yeah, no, this AI infrastructure bill, this was interesting. I mean, obviously, we don't really know a ton about it at this point, but you know, from what they've said, and it makes sense. You know, in order to have computation that is going to bring the AI stuff to the next level, they need to be able to build basically dedicated AI servers, you know, or supercomputers,
Mhm.
you know, infrastructure. And they're saying that they require so much power. They need to have an integrated, you know, a dedicated nuclear power source to be able to power these computers, which I found hilarious. They're like, oh my God. But you know what? I'm going to give credit where credit's due on the idea, and God knows what's going to come of it or whatever. But they're saying that they already have the technology in place, more or less, to be able to, you know, identify cancer before it ever even happens. For instance, they gave that as an example. determine these things through blood tests and then sit there and run all your blood test results and your genome more or less through the AI and have it actually figure out a specific vaccine for you that would nip it before it ever even manifests itself, which is crazy. That's the sort of use that you want to see this stuff being used for, and just God willing, it's isolated, secure, and not connected to anything. I hope that it's like information that you have to like send and then put in, and then it does it and gives you an output, because you know you don't want that connected to anything. Like that's
Yeah.
got to be its own thing, like separate of every, like, yeah, no connectivity.
Yeah, you know what? They always measure people based on their genes, and I think it's like the worst thing ever. And I'll tell you why. We were just talking about your brain and how each thing is connected in your brain, right? And how it's wired. Well, your genes really are not telling you how your brain's wired. It's, you know, the processes when you grow up, how each connection's made, stuff like that, which makes you either a psychopath or a normal person. So I would kind of like to do a brain scan instead of a, you know, where their genes came from. You know, it might help if it runs in the family, but most of the times it doesn't. It's just the outlier in the family who's just a psychopath, and there's nothing you can do about it, right?
Yeah, well, I mean, I think that that's you know, the brain mind connection, the consciousness connection has much to do with that. Like, you know, and it's so hard to really quantify, you know, for not going into a deep dive on that subject. But you know, realistically, there's a level of consciousness that exists that is the part that needs to be rectified. And, you know, people that are just stuck in those types of brain patterns, if you want to call it that, as far as like measurable stuff goes, for those types of disorders, I mean, you know, those people, they will not have light body. So go back to that episode. There's no light body there. It's unachievable. So
Yeah. Oh man. Yeah. Definitely some interesting things. Gerald ever going to get out and explain how he made his coil? Tried to watch it about a while back. I don't know that we'll ever learn that pattern. I will tell you that it's understandable, but I don't think we're going to learn it until that man goes on that thing and just tells you what it is. So, but do I think he's going to let it out anytime soon? I don't. I think he's got to prove out the theory, show everybody how it works and the things that it does before he ever lets it out. And then, honestly, once you learn what this thing does, I don't know that he would want to let it out unless he really did want to give everybody everything in the world.
well, I mean, he stated that that was the mission presented to him. So
if it is, man, we are in for a culture shock. Like, how can you ignore it? I guess I know more about that coil than I should say. All I say is once it's out, man, it's like, no putting no genie back in the bottle at that point. There's way too much going on there.
yeah,
But-
but that's the next step. It's the next step, and you know, I
mean,
just
look-
hope and pray that he gets everything together. So if he is going to make that decision to put that out there, that you know, he's able to do so. Well, it's, you know,
I mean,
still-
think
still
about
an
all the
option.
things that we talked about today. Over Unity, cold electricity. We're also talking about, I want to say transforming, but I know that's not the right word. What was the word, Joe? Transmutation.
Yeah.
He's doing all of those things. Not only that, he's got frequency going on there. So he's creating plasmoids inside of this thing. I mean, he's got all the harmonics, all the frequencies, all in a direct, specific order. So you say, well, we got the thunderstorm generator. Well, it's in there. Okay, you go, oh. 0 point energy. Well, it's in there. You go, okay. It's got cold and hot electricity running 180 degrees out of phase sometimes. Well, it's in there. It starts to scare you when you start adding it up, right? You're like, well, it also interacts with crystals. Well, okay. Is there something it doesn't do? Because I might be able to come up with a better list at that point.
Yeah.
You know what I mean? It's like totally different, dude. This guy's on another level.
Hey, Tim, thanks so much for that super sticker, man. That's really cool.
Tim, you rock, brother. Thank you.
Yeah. So, what was it? Elias, right? He said, show me a video. I'll tell you how it works. You know, we talk about is how it works. Okay. Like we know how it works. Okay. It's not what it's doing. Okay. It's what you have to do to get it to achieve what it's doing. So the how it works isn't any sort of mystery. It's literally the basis of this channel. It's the basis of all these deep dives that we end up doing. It's all the same exact processes. It's just simply how to achieve it at its higher levels. I was going to say highest, but I'll curb that and say higher levels. There's always probably some next thing, right? So, yeah, when the flow is right and has the proper interactions, has the proper flow, flow to make compression occur, where it's putting out, bringing in, compressing, putting out, and it's spiraling around it in such a way that's all, in sync, okay, and equilibrium with basically the universal energy that exists. That's the fabric of everything that is. When you have all of that stuff and it's close enough to that, that's when all of the extraordinary phenomena are available at that point. And we've said it 1,000 times, can't say it more than we already have, but we will. You don't just get one when you have it like that. You get it all. It's all there, all of it. And what do we mean? Well, it's energy. We said how these compression fields and whatnot, when it's expanse, when you're in the proximity of that expanse, how there's time dilation that occurs within that. There's a lot of different phenomena that exist within physics that we're well aware of that it could potentially occur when you have these things correctly. And it's just not a matter of the theory of it. It's a matter of how these things are situated in these interactions with the geometry, with how they cross over each other, how there's multi-dimensionality of the structure. That's what makes it happen. That's really what he hasn't shared. So, it's not quite as simple as necessarily just looking at it and being like, oh, okay. I figured this out. I mean, I'm not saying that that's not doable. It's just, that's the part of the process that isn't discussed. Is what that is. Yeah.
His time dilation stories are wild. Let me just tell you that right now. I was telling Phil the other day, you got to have both fields. In order to create time dilation, you have to have both fields. And he was telling me it was one field, and I was saying, no, it's two fields. And it's a separation in how you see it. And that's the wild thing, man, because my gravity flyer puts off a time dilation field in what it's doing in the room. It sparks up. Like when you run this thing crazy, it starts sparking up, man. It starts to fill the room. The whole room was filled with energy. You can feel it. You can feel it tingling everywhere. The mood has changed when you're in there. Okay? Let me just tell you that right now. So, yeah, it coincides. We were talking back and forth on it. It does the same thing, which is wild because this gravity flash sprays energy everywhere. So, it's pretty interesting, man.
It's not pretty interesting. It's probably the most interesting thing in the world.
Well, it'd be interesting if you sat in the room with me. You'd be like freaking out, dude. because it's wild, man. The energy that gets put in this garage, you trip out all day. So Sean keeps asking, what are we up to? The next plans? Sorry, Sean, I saw it several times. We had talked about it earlier, but we'll talk about it again. Joe and I were talking about crystals, and we're going to grow some crystals, or, we're talking about how to do it and what to add to it. And we're talking about adding frequency to it, hot energy, cold energy, putting in different fields. We wanted to use Epsom salt, regular salt. And Joe, you said there was a combination where it made a pyramid out of the salt. Which one was that?
Well, I mean, I'm not 100% familiar with the crystalline structure of Epsom salt, but when you're talking about first of all, it's two-dimensional. The way that it forms, so that's sapphire, right? So you'd have triangles, not pyramids, triangles that form in a rotational manner to ultimately create a six-sided, hexagon pattern.
So is it turning actually as it goes up, or is it just?
Well, I mean, mind you, I said the reason it's two-dimensional is because it grows on a plane and it's a plane of three. So you have one triangle there, and then it does a rotation, and then another triangle, and then a rotation repeating pattern. Now, I mean, that's why when you look at a piece of corundum or like crystal corundum or sapphire ruby, just generally, you'll see the outside of it always looks ridged. The reason it looks like it has ridges is because of this triangular rotational crystal structure that creates the six sides. And that's why the outside surface looks like that. I have a huge piece of corundum. The only thing is it's a mass piece of corundum, and it's also polished, so you wouldn't see the ridges. But when you pull a natural crystal out of the ground, that's how it generally forms. When they form, what I find fascinating though is when they form laboratory, rubies and sapphires. Usually that pattern's absent. They could form it in like a tube or a globule. So I don't really. I mean, I have my ideas as to why that would be, but I don't really know why that same pattern isn't achieved when molecularly it would be the same.
Well, we're gonna have to try it. Maybe
I think it has to do with the the resonance present during its formation. That's what I personally think. I think that when something's formed in the earth under those circumstances, it's going to be resonance based as to why it forms that particular way, where it's just simply not present in the laboratory.
Do you think we might get a beat frequency between the two and it changes the structure?
Be interested to know. I mean, beat frequencies are super interesting, especially when you could get them in such a form of modulation that you can get standing waves out of it, the standing waves that you want to get the proper crystalline structure and form. But not all beat frequencies are going to be compatible with the molecular structures that are accumulating to necessarily make the right thing. It would have to be the right combination of things, I think, in order for it to form the way you want it to. Yeah, I don't think everything would work out. I think that the certain beat frequencies could potentially lead to sloppy results, kind of.
So let's see what Tim's got to say here. Yes, but my understanding of everything in energy is electromagnetic, dielectric. Tesla had so much unbelievable intellect. Same with Paul Victor Schauberger. Yes. Both of them massive intellects, I'll be honest with you. But
yeah, next level stuff.
Yeah.
You know,
I,
they weren't working off of information that was available to them and then drawing sort of new logical conclusions or something like that. You know, they were finding this information themselves from observations of their environment around them, which is just it's just a far different dynamic. You know, that and just you know, having the imagination to be able to visualize something that's never been perceived. You know, that's the like there's geniuses out there that can make sense of a lot of things out of little bits and pieces of information. There's very few people that are true visionaries, and they were visionaries.
well, they kind of just worked on the flow of things, didn't they?
Absolutely.
I mean, that's what I do in my garage here. Is I work on the flow of things. If I see that it flows a certain way, I follow it right to wherever it goes. And it's not so much the science. So you could have all the theory you want. You know what I mean? Put it out in mathematical form, but I'm going to follow the flow. So I want to know where the energy goes, why it's going there, how it's flowing, what are the interactions between it. I think that's the most fascinating part. And
Absolutely.
I think that's where all the discovery comes from, isn't it?
I would say.
I mean, that's what rocks about it. By the way, I was looking at another project from Alt Propulsion, and it had to do with piezo discs. Okay, and you know I'm into that. So they had them in this little container, and once they hit the harmonic of it, it was moving, and then they hit a higher harmonic, and it was moving, and it was basically putting out a Tesla coil ring as it went, right? So my thought on it was they had them all glued together. Now, I would have them in a chamber that's not completely where they're glued together, like 1 to 1 to 1, but where they're in a container where it holds them on the outside, but that they can produce each frequency in between them along with the frequency of the piezo. So now you get a effect and a bounce off that effect. So if it's forcing the piezo in one direction, right, then it hits that thing. It has enough in it where it has a vibrational frequency to push it. So you get a force direction, right? Well, every single part of it, because you're only dealing in harmonics and frequency, your distance is massively important.
Mm.
If that harmonic is missed in each one of the placements, you're all off, completely off. You're going to get random frequencies that shoot all over the place, right? So every harmonic that your piezo puts off, your plates in between have to be able to pick up the same one. So you're in amplification mode. Okay. That I was watching that, and I was just coming to that same understanding that if you don't understand the harmonics in it, and I think that they do, but I don't think they take that into account because I can't tell the stack. You know what I mean? Because it looks like they're all glued together. I would prefer a 3D printed form that's glued together. You know what I mean? It snaps together. That would hold them all in the exact same place. You know what I mean? From 1 to 1 to 1. Then we can start amplifying the living daylights out of it. Because then now you know where the next harmonic is, right? So if I set it up and said, I want first chamber in first harmonic, second chamber in the second harmonic, third, fourth, and then I built it based on that frequency getting bigger, then I know the final output it should be the one that's really pushing it, right?
Yeah, yeah.
So that's the way I would particularly set that project up at, and it should have a lot more thrust in it.
Be interesting to see. All right,
Yeah.
hold on. I wanna address something that Sean wants to know about Crystal and his plasma discharge. All right, so Sean's saying what rock should he connect to the plasma discharges of his coils. So I would say that's, and I'm gonna give that some more thought, like off show, and I'll let you know too. But a couple things come to mind. The one variable that I would want to know is what are you trying to get out of that? You know, what are you trying to do with it? You know, I would say that if you're looking to you know, get better plasma show, like you're going to want a compound that is, you know, high in free hydrogen or something like that, because you know you have more free electrons to ionize. You know, if you're just looking to build plasma, I think that's what comes to mind right off the bat. So, you know, you probably like a calcite or something like that, because it's, you know, it's carbon and hydrogen mostly. Would probably be the thing that comes to mind right off the bat if that's what you're looking to do. But that might not be the ideal circumstance. And I would gladly look through just like you know, a couple crystal books that I have just to see because that becomes more of a chemistry question, I think. At that point, when you're talking plasma, because you're talking about energy interaction with matter as opposed to necessarily using a crystalline structure to exploit the electromagnetic properties of you know, your coil system at that point. You know, so there is a little bit of a differentiation there if that's what you were looking to attain. But what do you say? I feel like I'm a resident geologist with yeah. Well, I mean, listen, if you don't pick up what I put down by now, is like I'm a bit of a polymath. I'm into I'm into everything. So yeah, I appreciate that. I know a thing or two about a thing or two, and I'm always right unless I'm wrong.
So, do you know why we would want to know it, Joe? I give you the answer right now. It has to do with Ralph Ring and what he said about Otis T. Carr's machine. If you control it with your brain, right, you have to find something that works in the medium between your brain, energy, and the things around you. Okay?
Well, that
And
exists.
if he's using crystal to do it, okay, now we need to understand what's going on. Now we've already found energy. We found it traveling through water. We found the interactions. We want to look at which crystal we would want to use in that type of machine, like Ralph Ring was describing, in order to make this thing run based on it. Does that make sense?
Right. So the crystal that's already in our brain that is the most interactive of them all is magnetite, and that's been there, you know, all along.
But now, if it turns out that we need something different on the outside that we need to put in the actual craft, then we have to start looking at it and go, okay, which one interacts the best?
Well, if you're gonna look at it as an analogous to like a brain and a head, then you know your bone is made of bioapatite, right? So the form of apatite might, you know, crystalline apatite might actually be analogous. So if you know, it's sort of one of those things. Yeah, that's what your bone's made of, and that's also present in nature, you know. And what I didn't really know up until you know, fairly recently, and somebody filled me in on it, I didn't know it at all, was bioapatite has piezoelectric properties. You know, when I looked into that, what's super interesting is that in the electrical charge that it forms, the structure of the bone, as you know, it's porous, has pockets, right? Well, these charges actually get caught up into the pockets and actually, like sort of like ball lightning in the thunderstorm generator, for instance, right? These cold electrical forces actually get caught up in these pockets, create resonance for what it's worth, which is crazy, right? And actually, where the accumulations are in these pockets is where a lot of the joint attachments and things actually form from, and where a lot of the nerves ultimately come in and go to as well. Which, doesn't that sound like a plant, like where the plant likes to grow, right?
Yeah.
Where the cold energy is where the plant likes to grow. Where the cold energy is where the tendons and the nerves like to connect. It's, you know, there's a lot of you know, similarities and stuff like that, that go from one to the other. Your bones are constantly under stress. It's just another form of you know, energy that ultimately interacts with the sympathetic nervous system. So
I guess I just needed a place to start with which geode to look at to see interaction of energy. That was where I was going. It's all a starting point because it'll lead where it leads, but we need something to see the interaction so we know what to judge it by.
Right. Well, again, if it's analogous, I mean, what type of geode? I mean, you're not going to find an apatite geode because they don't form like that. But could apatite be formed in a way that it could, be used as an analog? I mean, it's not something I've ever really considered or looked into, but I suppose why not, right?
Well, that's kind of the question before us. You know what I mean? There's always a means to the end when we get there.
Right.
And they figured it out. Why can't we? Sean asked if my gravity flyer could be used in a cloud chamber. So you're talking about alcohol there, and then as soon as that gravity flyer sparks off with that energy, we're up in flames. So I don't think it'd be a great idea.
Yeah. You can use a cloud chamber, I'm sure, to see what the results are, but it can't be inside for the reasons, I mean, the only scenario that I can imagine that in is if you were to create an oxygen void environment, you create a vacuum and then you introduce your vapors and super chilled vapors, and at that point then you could probably have that without combustion, obviously, but the nature of alcohol vapor just in the presence of oxygen is just a bad fucking idea. Like, call it what it is.
Not only that,
In a container, there's a word for that. It's called a bomb.
as soon as you pull out some of that air in that chamber, you know what I mean? In any way, you're making those fields grow more than what you would normally put on the outside, so you don't know what's going to happen.
Yeah,
that's wild though. I put fog in there or something like that, or I'd love to try different lights. No kidding, man. I got those things, those covers for my light bulb, my 4-foot light bulbs. You see them right behind me, right on this side. Anyway, I put those out individually. I went and looked through every single one of them and all the energy forms that are in my garage. Now that's a trip because each one of them tells you a little bit differently. Some come out a little hazy. Some come out normal. You don't see nothing. It's kind of a trip, and I don't think those things are anywhere close to the right material, but it's a different color shade that goes into them. You know what I mean?
Yeah.
That's what I was looking for. So it'd be pretty interesting. I should probably do a video about that with different energies and show you what I was looking at. Because that right there, I just want to find any way I can to see this stuff without blowing myself up.
Yeah. Well, when you bring up color, I mean, that's always a good point, and probably something that's overlooked frequently in the experimentation is, anytime there's a color emission, you should be taking note of that, because you got to remember that, a color emission is just a wavelength that's, being let off of the system, and, like knowing what that wavelength is and what that means is actually significant to the system at hand. And if you're getting more than one color, like in that those photos that you shared last week when we were talking, where there's actually multiple colors and there's a separation of colors, and there seems to be forms of wavelength coherency of the colors that you're seeing. I mean, that's just an extra special phenomenon at that point. Now you have multiple things going on. You have an emission of coherent wavelengths, but then you also have wavelength separation that's occurring, which again is just super fascinating.
Yeah, one thing I discovered with that camera I didn't know before is it has different modes to it. So you can go like to a black and white mode on it, and then you can do the colors, and you can look specifically for cold areas or hot areas. So there'll be a lot more videos of that coming out. And the second that I see the movement of airflow around that rodent coil, it's over.
Yeah.
So one thing I was going to do was I had already saw that Michael did it when he did his. he put the wrap around the rodent coil already. He put an insulator, put a wrap around it every so often, so that he can make that flow. And I think I'm going to have to do the same thing. I'm going to have to choose the wire, put the energy in it, and just let it flow, and just make sure I put it in the right direction. Because last thing I want is the one go this way, one go this way. That would suck. You know what I mean? Or put it upside down where it's all going backwards. That would suck too. So I just have to make sure I check it and make sure I know which way the direction is going and which side north and south. That'd be it. I don't know. Maybe it's just me. I get kind of paranoid when I do that stuff. I always have to look at it like 5 times, make sure I'm not going in the wrong direction. I change where I'm winding my coil at one side of the table or the other, and I'm like, well, did I put it on this side last time, or did I put it on that side? Right? So, yeah, when you're winding 5 coils and then you switch sides of the table, you're like, what the?
Yeah. Well, it's like anything. Like, it's not. I can think of very few tasks that are super difficult. It's just a matter of knowing what you're doing. And being able to keep track of knowing what you're doing. It's nothing's all too hard. It's just knowing what you're doing and making sure that you're doing the right thing. That's it.
Yeah, I was tripping out that day, Joe. When I started pulling that Tesla coil apart, man, and I started making frequencies and stuff, it was bad enough to get a little bit of spark. That sucker started swirling. I'm going, wow.
Oh boy.
You know what the crazier part about this was? I knew what it was. So I had it close. I'm probably about this far apart in each coil. So that ring, when it goes like this, when you see it on the oscilloscope, it's so small, right? But in real life, it's the size of your field. So wherever your light stops at, that's where your ring is. You know what I mean? So think about it. So your outer layer is as far as your light will go, and then it starts to go down, then down, and then down. And that's where your Tesla coil ring is. So as I'm putting that thing out to it, it was close enough to pick up all that ring. So it must have hit 4 or 5 layers of it before it shot out the top.
Yeah.
And I don't think anybody really thinks about that. They always think, okay, what do they call that? When they put the water and then it comes out and it makes that ripple effect, right?
What are
longitudinal?
Okay, yeah. All right. Longitudinal wave.
So they put it out, right? It makes that ripple in the pond. Well, the bad thing is it's opposite of the way the Tesla goes. So the output, would be the higher amount, which you have to turn it like this. So think about it. The small end starts here at the bottom of the coil and grows to the bigger end. So the explosion is the rock dropping in the water. That's the explosion. That's opposite of the Tesla coil, right? In the ring, because it starts out small and gets really big, so the ring comes to the inside. So you have to think about it the same way, right? You don't start out big and then go to small. It's not what it's doing. It's ringing.
Well, remember, you could pull a rock out of water too, and it'd still do the same damn thing.
But there you go. That's about what we're doing here.
But it's it's observably the same, but it's actually opposite.
Yeah. So
are you taking a step with your right foot or your left foot first? That's the difference.
Here would be the cool thing. If I could put the geometry into my oscilloscope, it would literally not look like this. It would literally look like this. And when you now deal with a bipolar Tesla coil, the exact shape that you get is a tornado on the top and a tornado on the bottom. Mm-hmm. And you get it so they could do stuff. Because in a regular Tesla coil, the frequency and energy stop here and directed one way. But in a bipolar Tesla coil, it shoots out both ends. So now it's creating the exact field that you're looking for when everybody starts talking about the 0-point energy. They go, oh, we need a tornado on the top and bottom, and it to go like this around the outside.
Yeah.
Buddy,
Well, I
what do you
mean,
do?
what you're talking about right now just brings my mind directly to, the core of the Earth, how it stops spinning, and then you're dealing with potential for a pole shift. That's the difference. You have one going this way down, and then you have one going that way up, and in the middle, it's either going to be going this way, that way, or null zone.
Well,
When you're null zone, it's going to have to start spinning one way or the other at some point. If it starts spinning the same way that it was spinning before, then it's fine and dandy. It starts spinning the opposite direction enough. That's when you get
yeah.
that.
Well, you see, it's not flipping it like that though. It's like taking your primary and moving it a half an inch in one direction.
Right.
And then you have a pole shift. It automatically goes from north to south
Mhm.
just by moving it. So if you say south is my field that has less energy in it, that means that it's closer to that field, right? The primary. And then if you move it down, you know what I mean? It's closer to that field, so that has less energy in it. That's all that it is.
Yep.
That's what the flip is. But it creates all kinds of problems.
Well,
It doesn't actually flip it's just
right. It's like if you have two funnels at the end of a hose, and you just pour the water in one direction, then that's what it does, right? But if you bend the hose, then the water sits in the middle. But now if you flip the thing around, the water dumps out the other side, and then the water start going in the other side. It's just kind of how it goes. Like, it's I don't know. It's crazy shit.
if you see it as the flow comes off of the tornado and makes the circular structure, then that right there would be crazy because it may have to change direction. You know what I mean? Because it's flowing from top to bottom right now.
Yep.
Then it would have to go from bottom to top. So the actual field around the Earth may change.
It feels
That
like
might be the change.
it just feels like upper dimensional siphon is what it feels like an upper dimensional siphon. It's very interesting stuff. I don't know. Like, I mean, I guess I do have, I know, but I don't have words right now for it. Next week, I have to take the visual and turn it into words.
Well, it kind of makes sense in this way. If you took, God, that rodent coil, it's like 1/3 of what I want. You know what I mean? Maybe it's 1/4. It's just not everything I want in it. I want the field that goes this way. I also want the field that goes this way, but then I want the field that rings on both sides, right? And then I want it to also cap in. So I'm not getting what I want. I needed to rebuild it to make it one unit, but I guess that would be if you said I wanted to build a UFO out of it, I'd have to break them down into parts. I guess that's how I would do it. I'd have to put a Tesla coil inside of it while I added more structure to the rodent coil itself. But God, I'd have to change the entire size of wire and everything. It was way too heavy for everything. It could be completely out of balance.
Yep.
But if I just wanted to understand the flow of energy, then putting it on the table would be awesome.
Mm-hmm.
If we can find a way to see it. So,
Oh, I mean, there are interesting ways to be able to see at least the magnetic fields and so on, which, I mean, by deductive reasoning starts to help you see the other fields.
let me
so
ask you this: the alcohol thing. Can I do it in an open air environment? Would it
no,
have any effect? No.
because you need the density. The whole point is to achieve high saturation of alcohol vapor, and that in an enclosed area. So the same problem that you have with the fields just in diffuse expanse happens the same if you have an uncontained alcohol chamber, right?
Could I put it in the desert on a hot day where it looks like it's blurry and there's a ton of heat coming off the ground? Would it show a difference in it? trying to make anything work for me, Joe, where I can find it.
Give me 10 more seconds on this. Possibly, but like quantifying that result would probably be difficult because it's not a controlled that phenomena is not in a controlled enough environment, you know, to be able to pick out effectively the potential patterns that would be interfered with under those circumstances. So and how what the level of differentiation would probably be pretty minimal in that circumstance, because you're talking about light diffraction. So I mean, that's you would probably need sensors and computer measurements to be able to pick out the ambient pattern of it, and then be able to pick out the anomalies, and then be able to see what those anomalies are and what they amount to. So that's that's like a theoretical probably, but like, actually in practice seems impractical.
Okay. So, all right. I got another one for you.
Uh-huh.
Let me show you a picture. This is the
cool.
red light experiment that Alexi did on his gravity flyer. So the picture on the left shows where the field is. On the right, I identified it.
Mm-hmm. It's easy to see, sure.
Okay. So he used a red light and blurred the camera. So the remember the hot day thing? It changed the blur on it, right? So it's out of focus. But then he also used red light in the room. I'm wondering if that would work and show me the field.
Okay, so a trick that I use sometimes when I'm trying to take low quality images, let's just say, okay, and get out of them as much as you can, which is actually interesting because like you could sort of in certain circumstances turn this effect into like different types of x-rays. But what you could do is you can actually modify digitally a photograph, let's say for instance, right, all the different levels, okay, to raise and lower contrast. Now here's where the observability of this stuff comes in. All right, it's not so much in contrasting high or low, or color shifting from cool to warm, or it's not where the settings are necessarily as much as it is observing the fluctuation between the two, because what it does is it cycles through the pixels and changes them to different levels based on the hue, and that directly is in correspondence with the wavelength that was picked up on the sensor at the time. So by observing these high and low fluctuations, you could actually observe things that are there but aren't necessarily just clearly visible in the photograph themselves. When you find sweet spots on certain types of settings like contrast or exposures and stuff like that, you could leave those and then just shift the others left and right, and it's in that shift that you'll see things that aren't necessarily clearly visible will become more apparent. Okay, it's in that shift, in that movement of these particular settings. I mean, it's really, really effective for what it's worth most of the time. Like, there's things you could pick up on that just didn't photograph or visually. But how that works with field capture and stuff like that, I mean, I just never played with it to really say my experience with it. But I mean, I'm going off of like what you're showing me there, like that particular photograph, you could screw around with that and probably even get more detail out of it by utilizing that method.
Well, if he's showing that the red field puts off that energy of the center of the Tesla coil, which is around the center of it. That's what he's doing. If it
Yeah.
puts off that and it shows that, I just have to find the light bulb we used and then have the room lit up with it.
Yeah.
I mean, it's gotta be some way, because the only thing I see is he goes from normal camera to blurring the camera and do that. So he's messing with something like you're saying, like the pixels, and then he's got the red in there. So there's got to be a correlation to it so we can see it. And once we see it, everybody gets to see it. You know what I mean?
Yeah. Well, I mean, maybe it has to do with like they always say, like, I'm not pretending like I know something that I don't. It's like you hear the buzzword like red light shifts all the time, right? Infrared shifts, red light shifts,
Mhm.
ways to age things, and obviously there's a reason for that, to do with the wavelength, and its effect through its propagation that you could, you know, generally tell. So I mean, maybe there's something to it, you know. But again, I just don't have the experience with it to really have observed something to be like, yeah, okay, so I've seen this and this is how that works. So then that, like, you know, the photos are pretty self-explanatory. You can see the fields and what he's showing.
Yeah. So the only thing is you could build it and understand where it's going, you know what I mean? And
Yep.
the direction of wire and things like that. And it's able to be figured out. But I think most people want to see a visualization of what you're looking at. You know what I mean? In real time. You know, that's kind of where I was going with it, just to
Right.
give everybody what they were looking for.
Yeah, you know, it's weird because like light emissions, right, off of things, like almost everything has some type of photonic emission for the most part. Like not everything, but most things that run energy through it and are an incomplete and utter resonance, you know, like to have some type of photonic, you know, emission. And the weird thing, and I know a little bit, but not a lot about it, is how light interacts with other light isn't like how other field energies necessarily interact with each other. That's the, I think, case in point with that is the same as how like pigments don't mix the same as light color mixes, right? There's a
Yeah.
differentiation there. It's obvious why that's a differentiation is because you're dealing with an actual color emission versus you know, a reflection, and you know, mixture. So it's actually inverse. I don't know. Again, I just don't know enough about that really at this moment. You know, give me a week, I'll know all about it. I'll pray to God for the answers he'll give me or something, or maybe I'll look on the internet. You know, you never know.
Yeah, well, like I said, I just hope we figure it out sooner than later, and kind of give everybody a little bit more understanding of it. And then once we have the understanding, the science becomes easy. Then it's basically just build the, you know, what you're seeing in the field and what you're looking for. If you know the interactions, it becomes very simplistic. So
Yeah. All right, listen, Eighth Center just gave us some material for Star Trek. He says it's not the length that matters, it's the girth. What? No. What am I going to tell you? I mean,
oh, that's definitely going in there, Joe.
oh yeah.
Oh, that's so great. All right, Joe, it's been 3 hours today.
Yes, sir.
I think we're about done.
Yeah, well, it's been real as always. It's been a nice little episode we got here. You know, if everybody in the chat could do me a favor, if you know somebody that might care for this sort of thing, go ahead, send it around, share it and stuff. I think our last week's episode was in the 800 view kind of range, and that's looking really good. And we just want to make sure that this stuff is getting out there to as many people as possible. And I would love to see this episode get to 1,000. I think that would make my day. You know, as I, you know, I don't know if you know this or not. I mean, I come on here because Nathan's my friend and I love talking to him and I love engaging with the community and stuff. You know, there's nothing really out here, you know, that I'm getting out of it. So seeing that a video makes 1,000 views, I think that's huge for me personally. Like that's as much of a reward as I could ever ask for. So please, you know, share it and get it out there and like and subscribe, obviously, if you have it. And if you got a couple of bucks to share, to keep things running for Nathan, join, be a member, all that great stuff,
Yeah, I want to say thank you to. I'm sorry. Excuse me. I want to say thank you to Tim today for hooking us up, man, with that donation. I really do appreciate it, bro.
Yeah, man, that's really cool.
So I'm going to put Joe's channel here in the chat for you guys. So you guys can go over there and sign up for his channel, man, and subscribe. It's really awesome. There you go. Right there in the chat.
And
With
as
that
always,
said-
people, peace, love, fuck Brandon.
That's just not right to say. Brandon, we still love you, man. Don't let Joe do that to you. Anyway, guys, I just want to say thank you to everybody, guys. You guys have been great. All the chat. Totally awesome. We'll talk to you guys later, man.
Peace
Have
and
a
love.
great day.
Have a good week, everybody.